Característica de Toad, y es sobre el editor de Toad se trabajó bastante. Quest tiene dos herramientas que son Toad y SQL Navigator. ¿Alguien conoce aquí SQL Navigator? Ok. Las dos herramientas se mantienen. Muchos usuarios de SQL Navigator empezaron con SQL Navigator porque el editor era muy avanzado. El editor tenía características que hace 6 años Toad no tenía. Entonces era muy avanzado ese editor, tenía, autocompletaba código, mostraba los objetos de la base de datos. Sobre Toad se trabajó bastante. Se mantienen los dos. Navigator se mantiene exclusivamente para desarrollo, mientras que Toad hace desarrollo, pero Toad puede crecer hacia la parte de administración de base de datos. Por eso se mantienen los dos productos. En Europa, Navigator es muy popular. O sea, la base de datos instalada en Navigator es muy grande y por eso el producto no se eliminó, ¿sí? Entonces se mantienen los dos y el único que crece hacia la parte de administración es Toad. Incorporamos características como texto predecible. Aquí ustedes ven que yo coloqué la S y él me propone si es un select, si es un set point. Entonces yo puedo seleccionar mi instrucción select y continuar con la ejecución de la consulta. Si cometo errores, entonces me lo subraya en rojo como si fuera Word, y también con botón derecho me muestra cuáles son las opciones para corregirlo. Entonces voy con mi consulta y me aparecen los objetos a los que les puedo hacer la consulta. ¿Sí? Pues aquí tengo mi query y con Shift F9 lo ejecuto y tengo mi set de resultados. Ese set de resultados, Toad ha evolucionado bastante en lo que tiene que ver con el hecho de que ustedes generen un archivo plano. Muchas veces necesitan la herramienta para generar archivos planos y llevarlos a otros ambientes. Así que con Toad pueden generar un archivo plano, un archivo de Excel, tablas HTML, instrucciones insert, archivos de SQL Loader. Y algo muy interesante que tiene la última versión de Toad es la parte de data masking. Si ustedes quieren enviar datos, pero determinadas columnas quieren que tengan enmascaramiento, entonces utilizan el componente de data masking. Y de estas columnas que tienen mi archivo plano, yo puedo convertir alguna en valores aleatorios. Entonces, nombre de departamento, podría buscar nombres de departamento e incluirlos dentro de la generación de mi archivo plano. Estos datos vienen de una lista propia de Toad. Entonces no salen los datos de producción, sino que salen enmascarados, pero con significado. Aquí tengo el query, y ustedes ven que escribí el query en una sola línea y no tiene ningún estándar. En Oracle, en el optimizador de Oracle, pasa algo bien interesante, y es que si yo tengo este query acá y si le dejo espacios, los dos queries generan el mismo set de resultados, pero para el optimizador son diferentes, así que el optimizador hace parsing 2 veces para este mismo query. Al no seguir mejores prácticas, pues cada uno de los desarrolladores va a tener su estilo de escribir consultas, uno en mayúsculas, otro en minúsculas, y si escriben el mismo query, pues el optimizador procesa 2 veces lo mismo, y no tiene sentido. Así que con Toad ustedes pueden aplicar formato. Esta pinturita es el botón de formato, donde yo estoy aplicando formato para mis consultas y entonces ya mis consultas quedan idénticas. Yo puedo definir ese nivel de formato, si quiero que sea todo en letras mayúsculas, minúsculas, palabras reservadas, cuánto espacio para indentar, espacio entre paréntesis, la posición de las comas, si quiero la coma al final de la columna en un select o quiero la coma antes de la columna en el select. Todo lo organiza Toad de forma automática. ¿Sí? Y entonces de aquí vayámonos al query que tenía problemas, que es este query. Voy a ejecutarlo y me genera mi set de resultados. Entonces voy a hacer una sesión de afinamiento con la consulta. Toad tiene dos opciones para hacer afinamiento. Hay una opción que se llama Auto Optimize y otra que se llama Optimización Avanzada. Las dos las pueden acceder ustedes desde el icono de optimización. Hay una tercera que es Oracle Tuning Advisor, y es cuando ustedes tienen licenciados los paquetes de Oracle para que puedan utilizar esos paquetes dentro de la interfaz de Toad. Si no tienen licenciados los paquetes, pues no importa, Igual Toad hace la optimización de forma propietaria. Entonces veamos las opciones de Auto-Optimize. ¿Por qué se tienen dos opciones? Auto-Optimize está más orientado a aquellos desarrolladores que tienen un enfoque principal en Java o en otros lenguajes de programación, pero que igual necesitan hacer un query a la base de datos. Entonces su conocimiento principal no es PL, pero quieren hacer un query afinado. Así que esta opción les pregunta si la base de datos es de transacciones en línea o es un data warehouse, ustedes definen, y el nivel de inteligencia de la herramienta. El nivel de inteligencia se refiere al algoritmo que se utiliza para reescribir la consulta. Nivel 1 es un algoritmo sencillo, rápido, menos alternativas, y nivel 5 es un algoritmo más complejo, tarda más tiempo, pero encuentra más alternativas. ¿En qué se basa la optimización que hacemos? Se basa en tomar el query, reescribirlo en factores algebraicos y la herramienta empieza a hacer permutaciones y combinaciones. Todas las permutaciones y combinaciones posibles para encontrar planes de ejecución diferentes. Entonces la optimización se basa en encontrar planes de ejecución diferentes al original. Es lo que va a empezar a hacer la herramienta. Pues aquí ya les muestro un ejemplo con el proceso. Si encuentra un plan de ejecución diferente, se ejecuta el query, que es lo que vemos aquí. Me dice que la alternativa 175 tiene una mejora del 88% en el tiempo de respuesta. Entonces podemos ver la instrucción a la que le quiero hacer afinamiento, la mejor alternativa que es esta, y puedo compararlas. Puedo comparar la forma de escribir el query, en qué cambió. ¿Sí? Aquí se colocó un order by. ¿Y cómo cambia el plan de ejecución de las dos? Entonces, utilizando la herramienta, pues ya encontré una que es 88% más rápido y simplemente la selecciono y la reemplazo en el código fuente. ¿Bien? Esta es la opción de Auto Optimize, no se necesita tanto conocimiento de PL. Y está la opción de optimización avanzada. Entonces, vamos a ir al query, ese es el query, y me voy a la ventana de optimización avanzada. Voy a abrir ese mismo ejemplo. Y aquí ya tenemos un laboratorio completo para hacer el afinamiento. Del lado izquierdo, aquí está la consulta a la que le quiero hacer afinamiento. Puedo ver el plan de ejecución. Lo interesante de Toad, por ejemplo, es que disminuye la curva de aprendizaje. Si ustedes no saben lo que es un hash join con botón derecho, pueden ir a la ayuda y van a ver la documentación de lo que es el hash join, un ejemplo y cómo lo interpretan cuando lo ven en el plan de ejecución. También pueden cambiar la forma de visualizar el plan de ejecución, lo pueden ver gráfico, pueden colocar animaciones que presentan los pasos que se hacen al tiempo. Lo pueden ver también en la forma en que lo presentaría SQL Server. Y el nivel de detalle que se incluye en el plan de ejecución es personalizable, ¿no? ¿Qué tanto detalle quieren ustedes incorporar en la información que se muestra en cada ítem del plan de ejecución? Luego está la información de la consulta. ¿Por qué se clasifica como problemática? ¿Cuál es el problema que tiene esta consulta? Y también tengo información del esquema. Y esto es bien interesante para desarrollador que pueda identificar si los problemas en el esquema son porque no se han recolectado estadísticas. Aquí puedo ver para las tablas que forman parte del query en qué fecha se recolectaron estadísticas. Entonces puedo identificar si el problema de performance tiene que ver es con estadísticas y es un problema del área de DBA o si es un problema real de desempeño de mi consulta. Y tengo dos opciones para hacer afinamiento a la consulta. La primera es la reescritura con el nivel de inteligencia que les mostré en el primer paso. Y la segunda opción es buscar índices en alguna de estas tablas que hagan que la instrucción se ejecute mucho más rápido. Y la búsqueda de índices también tiene que ver con un nivel de inteligencia. Entonces, ejecuto el proceso de reescritura y generación de índices. La herramienta va a empezar a hacer el proceso. En ese proceso, el consumo es local, o sea, CPU local, no hace nada en el servidor. Yo puedo proponer mis propias alternativas y veamos el resultado. Para optimización se utilizó nivel 2 y se encontraron 204 alternativas que generan un plan de ejecución diferente. Así que tengo 204 alternativas para probar, de 800 formas posibles de escribir ese query. Y la herramienta tardó 1 minuto 20 segundos en encontrar estas 200 alternativas. Yo me imagino que a ustedes les ha pasado que están en desarrollo y llevan un día, 2 días pensando cómo hacer un query y se lo están imaginando, lo están craneando, duran esos 2 días, lo crean, lo ejecutan y luego el DBA les dice que no, tienen que cambiarlo porque eso afecta el desempeño de la base de datos, se va para el piso. Cambiar el paradigma después de que uno estuvo 2 días pensando cómo hacer un query de una forma específica no es tan fácil, no es tan sencillo reescribirlo mentalmente para que cambie el plan de ejecución. Y aquí en 1 minuto encontramos 200 alternativas de plan de ejecución diferente, es lo que vamos a probar. Para índices se utilizó el nivel 3 y se encontraron 2 índices que generan planes de ejecución alternativos. Entonces tenemos esas alternativas para probar. Venimos a un proceso de comparación. Aquí tiene que ver mucho la experiencia de cuáles son los que yo quiero probar. Entonces tengo la original y las diferentes alternativas para comparar la forma de escribir, para comparar el plan de ejecución entre ellos. Una vez he definido cuáles quiero ejecutar, empieza el proceso de ejecución. O sea, hasta acá fue encontrar todos los planes de ejecución posibles, pero ¿cómo saber cuál es el más rápido? La única opción es ejecutarlos. ¿Puedo ejecutarlos todos o solamente los que seleccioné? Y esto es algo bien interesante, que es un sistema experto que me determina cuántas veces se va a ejecutar cada una de las alternativas con base a las preguntas y a cómo yo alimente el sistema experto. Me pregunta dónde está siendo utilizada la consulta. ¿Es un reporte o es un proceso batch? ¿Es un programa en línea? ¿Es una consulta que viene de un application server? ¿Está dentro de un bloque de PL/SQL? ¿Es un SQL dinámico? ¿Se ejecuta pocas veces al día o cientos de veces por minuto? ¿Y qué ocurre cuando se ejecuta el query? Aumento de consumo de CPU, aumento de consumo de I/O. Defino eso para que la herramienta empiece a ejecutarlo y empieza la simulación. La simulación sí va contra la base de datos. Entonces ya empiezo a ejecutar mis consultas. Así que un proceso de afinamiento puede ser tan rápido como hacerlo en 15 minutos, 20 minutos, o puede llegar a tardar días para hacer el proceso de afinamiento y probar todos los escenarios, ¿no? Yo esta interfaz la puedo almacenar y continuar al día siguiente para hacer las pruebas. La herramienta al final genera un reporte, todo documentado dentro de mejores prácticas. Y aquí vemos, por ejemplo, que la mejor alternativa es la 34 y se ejecuta 2.3 veces más rápido que la instrucción original. Y estoy documentando el proceso. Entonces tengo ya documentado la sesión de afinamiento para mi consulta SQL y lo único que debo hacer es tomar esa mejor alternativa que es la 34 y reemplazarla. Aquí estoy utilizando hints, yo le puedo configurar la herramienta que utilice hints o que no utilice hints, ¿sí? Eso es parametrizable. Así como hago afinamiento a un query específico problemático, también puedo hacer afinamiento proponiendo índices, capturando todas las consultas SQL que se ejecuten en un intervalo de tiempo. Entonces yo podría poner a la herramienta a capturar las consultas SQL que se ejecutan de 8 a 5 de 8 de la mañana a 5 de la tarde, capturar todas esas instrucciones SQL desde la SGA y luego que la herramienta proponga índices en esas tablas a las que se les están haciendo consultas. ¿Sí? Voy a tener información como con cuál índice voy a mejorar qué instrucciones SQL. Con este índice mejoro esta instrucción SQL y reduzco su plan de ejecución en un 50%, el costo del plan de ejecución. Se puede hacer optimización batch, que es todo lo que les mostré de forma manual, lo hace él automático. Entonces programo un job para que un fin de semana analice todos los procedimientos en la base de datos, identifique consultas problemáticas, las optimice y luego las ejecute. ¿Sí? Al ejecutarlas me va a decir qué tan rápido se va a ejecutar cada uno de los queries. Veamos un ejemplo acá. Esta, por ejemplo. Este procedimiento tiene una consulta problemática y tiene una consulta simple, y la mejora sobre la consulta problemática es de 10 veces. Es ese query el problemático, si coloco la instrucción del order by, se ejecuta 10 veces más rápido que la instrucción original. Entonces ya tengo el reporte y simplemente es hacer el cambio si requiero hacer el cambio. Puedo detectar consultas problemáticas a nivel de procedimientos, funciones y paquetes o archivos planos, o a nivel de la SGA. Y algo bien interesante para los DBAs es el análisis de impacto. Muchos DBAs crean un índice en la base de datos, mejoran un query, pero 10 queries más se ven afectados por el índice que se creó. Entonces, análisis de impacto ayuda al DBA a hacer esa verificación antes de hacer modificaciones. Simula la creación del índice, verifica cuál es el impacto que se tiene sobre todos los queries que llegan a esa tabla y nos muestra un reporte indicando si se mejora o no el plan de ejecución, el costo del plan de ejecución de esas consultas. Esto lo permite hacer análisis de impacto para índices. Si cambio un parámetro de la base de datos, cuál es el impacto que voy a tener, y puedo comparar diferentes bases de datos también para hacer ese análisis de impacto. ¿Hasta aquí alguna pregunta? Listo. Ok. Vamos entonces hacia el concepto de mejores prácticas en desarrollo. Ya vimos problemas por la lógica del programa cuando hago depuración, problemas por los tiempos de respuesta y problemas por el afinamiento. Pero también hay muchos problemas en base de datos que tienen que ver con mejores prácticas, por no seguir mejores prácticas en desarrollo. Por ejemplo, si yo declaro una variable que se llama h y llega otro desarrollador y empieza a leer ese código, pues él se va a demorar en entender qué significa h, porque no seguí mejores prácticas donde tenía que a una variable darle un nombre significativo para que se entienda en el contexto. Entonces, esas mejores prácticas las podemos analizar con el Code Analysis. Me regreso a Toad, tengo el procedimiento con el que estoy trabajando y ya lo revisé, ya verifiqué, ya hicimos afinamiento. Y ahora quiero ver si se están siguiendo mejores prácticas en ese código. Para eso lo envío al componente llamado Code Analysis, es este icono, y voy a hacer el análisis sobre el procedimiento. Code Analysis tiene cerca de 190 reglas de mejores prácticas. Este módulo lo desarrolló Steve Forrestein. Si ustedes tienen el Oracle Magazine, Steve Forrestein tiene una columna en el Oracle Magazine y durante varios años fue considerado el mejor programador de PL/SQL del mundo. Entonces, él desarrolló estas mejores prácticas. Tienen diferentes objetivos: lectura, estructura del programa, eficiencia, mantenimiento, y tiene reglas críticas de advertencia o simplemente de carácter informativo. Cada una de estas reglas está programada con un lenguaje llamado XPath. ¿sí? Que es de código libre en internet. Eso significa que ustedes pueden tomar la regla y la pueden personalizar, pueden hacer modificaciones a las reglas para buscar cierta información en el código de su compañía o utilizar las reglas que vienen ya por defecto en Toad. Entonces vamos a empezar el análisis, las 190 reglas. Ya aquí tengo el resultado. Hay 16 violaciones a mejores prácticas y puedo verificar qué está ocurriendo con esas reglas de mejores prácticas. La primera, por ejemplo, procedimientos que no reciben parámetros. Por mejores prácticas, todos los procedimientos, los más pequeños, deberían recibir parámetros para un crecimiento futuro. Tengo variables que no se declararon, cada una de ellas no se declaró un valor, no se inicializaron con un valor por defecto. Y aquí les voy a mostrar una muy sencilla, pero que nos hace el resumen de lo que son mejores prácticas. Esta regla es de carácter informativo, así que no afecta el tiempo de respuesta, ¿sí? El tiempo de respuesta va a ser el mismo, pero su objetivo es lectura y tiene que ver con lo siguiente. Cuando ustedes están leyendo un programa de PL/SQL y empiezan a ver la instrucción en y luego ven en, pues le toca a uno casi que con el dedo empezar a mirar, bueno, este en que termina y que está terminando, y se regresa uno y vuelve y se demora mucho tiempo leyendo un programa y es solamente leyéndolo y perdiendo tiempo. Por mejor práctica, cada instrucción en debería tener una etiqueta indicando qué es lo que estoy finalizando. Entonces aquí está incorporado, esta es la mejor práctica. Entonces, como ven, no me afecta el tiempo de respuesta, pero sí cuando voy a leer y hacer mantenimiento a mi programa. Entonces, a eso van las mejores prácticas. Esas son las 190 que ustedes pueden personalizar, pero adicional a eso, puedo ver las propiedades, ¿sí? Cuántos cursores hice open y a cuántos les hice close. Análisis de declaraciones, variables que se declararon sin valor por defecto, análisis de ML, qué tipo de instrucciones y cuántas, y este es bien interesante, análisis de secciones. ¿Acaso el DBA está colocando código en producción que no maneje secciones? Si aparece un error Oracle, inmediatamente le sale la ventana al usuario final de Oracle. Entonces el DBA puede utilizar este componente para regresar el código a desarrollo. Y bueno, aquí hay todo un análisis de complejidad, y el análisis de complejidad me permite a mí indicar si se autoriza o no se autoriza el código en producción. Hay 4 aspectos de complejidad: número de instrucciones, complejidad computacional, complejidad de ciclos y mantenimiento. En complejidad computacional podemos ver, yo lo vi en ingeniería de software, pero yo creo que a todos nos pidieron calcular la complejidad de un algoritmo. Entonces nos daban un algoritmo, cada operador aritmético y cada operador lógico tenía un peso, uno calculaba el peso, el volumen, la dificultad del esfuerzo y podía decir qué tan complejo es el algoritmo. Es lo que hace Toad de forma automática en el programa. Entonces analiza y al final, si es entre 0 y 1000, se puede autorizar la puesta en producción, y si es mayor a 3000, pues es un candidato a reescribir completamente ese código para disminuir la complejidad, ¿no? Como dato curioso, a Steve Forestein, los programas de PL, según él, deberían tener máximo 20 o 25 líneas de código, ¿sí? Más allá no era razonable tener programas con tantas líneas de código. La complejidad debería estar reducida a esas líneas y más bien ser llamados a cada una de las funciones para crear un procedimiento, ¿no? En Latinoamérica no se ve mucho eso, ¿no? Normalmente un programa de PL en Latinoamérica debe tener sus 200 o 500 líneas de código para sentirnos contentos con ese código. Esas son las mejores prácticas en lo que tiene que ver con desarrollo. Me regreso a esta herramienta. ¿Sí? El componente de Code Analysis para mejores prácticas. Ahora vamos a la parte de pruebas. Pruebas y más pruebas. Normalmente no se realizan las pruebas necesarias en desarrollo para asegurar que el programa es lo suficientemente robusto en producción, ¿no? ¿Qué es lo que ocurre en desarrollo? El desarrollador sabe qué tiene que probar en su programa y también sabe por dónde no meterse porque sabe que no hay validaciones. Entonces hace el programa, lo mandan a producción, le colocan la bendición y que nadie se meta por donde no tiene que meterse. Entonces, para eso tenemos un componente llamado Code Tester. Code Tester permite hacer esas validaciones. Cuando se empieza el desarrollo de un programa, se sabe cuáles son las variables de entrada y también se sabe pues, qué es lo que se espera que genere el programa. Entonces, Code Tester se basa en eso, con base en los valores de entrada, cuáles son los valores esperados de salida y empiezo a crear escenarios y los voy guardando en un repositorio. Durante todo el ciclo de vida de desarrollo de mi software, pues voy validando mi primera versión contra el set de pruebas. Y así hasta que el programa sea lo suficientemente robusto para poder autorizar la puesta en producción. ¿Sí? La idea con este componente es que los desarrolladores se sientan orgullosos de su código. O sea, que digan, sí, este es el código que hice. Cuando sus hijos lleguen a la compañía, digan, ah, este es el código de mi papá, y funciona, y tiene mejores prácticas. ¿Sí? Así como tenemos ese Code Tester, hay componentes para generación de datos, que es el Data Generator, que permite generar datos de prueba, ¿sí? Que en desarrollo puedan subir las tablas con N registros para hacer pruebas, con valores con significado, como lo mismo que les mostré del Data Masking, pero ya para llenar toda una tabla. El Data Subset Wizard es un componente que me permite hacer un export del ambiente de producción, pero por porcentaje. Decir, quiero el 20% del ambiente de producción para subirlo en desarrollo y hacer pruebas con ese porcentaje en desarrollo. Está Benchmark Factory, que me permite hacer pruebas de escalabilidad. Entonces, Benchmark permite simular concurrencia, simular usuarios conectados a mi base de datos ejecutando transacciones, N usuarios ejecutando transacciones. Y Code Tester, que es el programa de las pruebas que les mostré. Esta es la interfaz de Code Tester, son unidades, pruebas unitarias. Code Tester fue la primera herramienta que permitía hacer eso en Oracle. ¿Sí? Así que tiene más de 3000 sets de pruebas por tiempo, por variables retornadas, por excepciones retornadas en Oracle que se pueden definir y calcular. Y Benchmark Factory, les muestro un ejemplo de Benchmark Factory. Aquí ustedes ven que en la optimización, la mejor alternativa es la 34, pero está la 24, la 31 y la 93. Por centenas es lo mismo, la diferencia deberían ser décimas de segundo, así que ¿cómo sé yo de estos 4 que les muestro? Los 4 fueron afinados y los 4 me dan los mismos tiempos de respuesta. ¿Cómo saber cuál es el que mejor se va a comportar en producción? Porque aquí fue una sola concurrencia, solamente una ejecución. Entonces para eso utilizo Benchmark Factory. Yo puedo simular la concurrencia con Benchmark. Les muestro cómo hago el proceso. Entonces vamos a ejecutar aquí los reportes. Y aquí tengo el resultado. La instrucción original y las diferentes alternativas. La 34, la 24, las 4 que les mostré, las mejores alternativas. Y simulé hasta 25 usuarios concurrentes. Entonces tenía aquí un usuario, 5 usuarios, 10, 15, 20, 25 en el eje de las X y en el eje de las Y el tiempo de respuesta. Y vemos el comportamiento de la instrucción original, su tiempo de respuesta hasta cuando intenta estabilizarse, y la mejor alternativa que resulta la 93. Entonces, la 93 es una instrucción afinada que también tiene un mejor comportamiento en concurrencia. Aquí puedo simular N usuarios concurrentes ejecutando esa sentencia y definir cuál es la mejor para el ambiente de producción. Entonces ven que se cierra todo un ciclo de mejores prácticas para garantizar la calidad del código en el ambiente de producción. ¿Hasta aquí alguna pregunta? Listo. Y para la parte de monitoreo y diagnóstico, pues es como lo que mantiene siempre con dolor de cabeza al DBA, tiene que estar pendiente de múltiples ambientes. O sea, en el mejor de los casos es solamente Oracle, pero normalmente es Oracle, SQL Server, DB2, un MySQL, un Sybase. Tiene que estar apagando incendios constantemente, cualquier alarma tiene que mirar qué es lo que está ocurriendo, así que no se tiene tiempo para innovar o investigar en otras tecnologías. Entonces se necesita un cubrimiento total del monitoreo. Todos los componentes de Oracle, o sea, Oracle no solamente es Oracle y su base de datos, pueden tener configuraciones de DataGuard, de cluster con RAG, la replicación de DataGuard. El storage puede ser diferente, ¿sí? ASM, el área de flash, table space, data files, hacer verificación de los objetos inválidos, tecnologías recientes, o sea, un DBA va a tener su Oracle 10, su Oracle 11, su Oracle 12, en el mejor de los casos 11 y 12, y tiene que estar monitoreando los dos. Ideal que pueda hacer un análisis histórico de lo que está ocurriendo en cuanto a performance, que pueda identificar bloqueos, cuál es el motivo de los bloqueos, si la base de datos se cayó el domingo, que pueda hacer un análisis forense y determinar qué fue lo que ocurrió el domingo para que la base de datos se cayera. Entonces, ese tipo de análisis lo podemos tener con herramientas que nos visualizan toda nuestra infraestructura. Aquí estamos viendo nuestras bases de datos SQL Server, Azure, Oracle y otros motores de base de datos. Entonces tenemos 7 instancias Oracle y podemos ver cuáles alertas se están presentando en esas instancias Oracle. ¿Qué está ocurriendo? Tengo 376 alertas, 2 críticas y 374 warnings en mi base de datos. Puedo hacer análisis de carga de trabajo. Y les voy a mostrar esto que es bien interesante para el monitoreo. Este es un ambiente que tenemos en la nube. Entonces, permítanme, me conecto de nuevo y les muestro cómo hacemos el monitoreo de toda la infraestructura. ¿Alguna pregunta de lo que les he mostrado? Ok. Listo. En este ambiente ya tenemos diferentes motores de base de datos, tenemos diferentes configuraciones, tengo Oracle RAC, se tienen diferentes máquinas. Y les muestro la interfaz de monitoreo. El monitoreo se hace a través de un browser. Entonces vamos a monitorear todas las bases de datos y consolidar en un solo browser. Listo. Esta es la consola principal. Y aquí tengo la interfaz principal. Monitoreando todas mis instancias, aquí puedo ir a mis instancias Oracle y puedo identificar si tienen algún tipo de problema. Vamos a lanzar algo de actividad. ¿Listo? Y puedo profundizar sobre ellas. Entonces vamos a nuestra base de datos de Oracle, que tiene una alerta. Puedo ver el tiempo de disponibilidad, si tiene configurado alta disponibilidad o no, información de la infraestructura, información del desempeño, y puedo ver el overview sobre ella, la actividad en cuanto a sesiones, bloqueos, y la vista en tiempo real, se la voy a mostrar, es muy similar a lo que tenemos en Spotlight. Donde vemos el flujo de información desde que se conectan las sesiones, actividad de los procesos, lecturas en disco y lo que está ocurriendo en la base de datos. Ahora, en cuanto al análisis multidimensional que les estaba nombrando, tenemos este componente que se llama Performance Investigator. Performance Investigator es análisis multidimensional, es una especie de cubo que maneja varias dimensiones. La primera dimensión es el tiempo. Yo puedo analizar los últimos 60 minutos, o sea, en tiempo real, o me puedo ir a una fecha específica en el tiempo, ¿sí? Voy a tener un repositorio con la información. La siguiente dimensión es lo que yo quiero analizar: carga de trabajo, CPU, I/O, aplicaciones, concurrencia. Entonces vamos a ir con carga de trabajo. Y la siguiente dimensión es el componente específico de Oracle. Entonces, ¿qué significa esto? En la última hora, ¿qué es lo que ha contribuido a la carga de trabajo en mi base de datos? Entonces puedo ver instrucciones SQL que afectan carga de trabajo. Voy a tener la información de esas consultas SQL, pero ahora quiero profundizar en el detalle de qué máquina está ejecutando esa consulta. Entonces esta es la primera consulta, la que genera problema. Puedo ir al usuario del sistema operativo que ejecutó la consulta, el usuario de base de datos, la máquina desde que se ejecutó la consulta, ¿sí? O el programa específico que ejecutó la consulta. Y ya sé que es SQL Plus. Y puedo ver cuál es el usuario de base de datos. Entonces esta es una vista multidimensional. Voy a llegar específicamente al detalle de lo que está ocurriendo en mi base de datos a nivel de monitoreo. Como tengo un histórico, también puedo identificar cambios. Puedo identificar si la afectación de desempeño es porque se creó un índice en mi base de datos o porque se borró un índice en la base de datos. Comparar a nivel histórico lo que está ocurriendo en mi base de datos y tener recomendaciones. Performance Investigator hace recomendaciones de cambios en la configuración de Oracle para mejorar el desempeño de mi base de datos. Entonces puedo hacer ese seguimiento a cambios de lo que está ocurriendo en la base de datos. En un monitoreo desatendido 7×24, donde no se requieren agentes en la base de datos, en las diferentes instancias de base de datos. Ese es el componente de monitoreo y el análisis multidimensional. Otro de los problemas son migraciones, que ustedes se mantengan en versiones anteriores de Oracle porque son bases de datos 7×24 y no tienen tiempo o una ventana suficientemente grande para hacer la migración. Hay diferentes razones para migrar, porque cambian sistema operativo, porque quieren cambiar hardware, porque quieren cambiar la versión de base de datos, y para eso nosotros utilizamos SharePlex, que es nuestra herramienta de replicación y de alta disponibilidad, que permite hacer migración con cero impacto, ¿sí? Este SharePlex es como un equivalente a lo que es GoldenGate, pero con características técnicas diferentes, como por ejemplo, que ustedes puedan hacer procesos de activación sin bloquear objetos, o características como que cualquier cosa que se coloca en los redo logs es replicada inmediatamente, y de lo que se coloca en los redo logs se requiere solamente el 30% de la información, así que está diseñada para trabajar en ambientes altamente transaccionales, donde yo pueda replicar de Oracle a Oracle sin afectar el desempeño de mi base de datos o sin consumir recursos adicionales. Una migración es muy sencillo. Tengo mi ambiente de producción actual, instalo SharePlex, empieza a capturar todas las transacciones que se realizan en la base de datos. Dentro de la arquitectura de SharePlex quedan en colas dentro de SharePlex todas esas transacciones. Mientras todas las transacciones se capturan, yo puedo hacer un export de la base de datos o un datapam export, y la base de datos sigue disponible. Hago el export y hago el import en el nuevo ambiente de producción. Entonces puedo haber cambiado de hardware, haber migrado de sistema operativo o simplemente pasar de Oracle 10 a 12, y mientras hice el cambio no afecté el ambiente de producción. Eso significa que puedo hacer la migración un lunes en la mañana y no tengo que programar el fin de semana o programar Semana Santa o Navidad para hacer migraciones. Si no lo hago un lunes en la mañana, mi base de datos de producción siempre estuvo disponible. Y cuando ya tengo listo el nuevo ambiente de producción, hago un proceso de reconciliación, que es aplicar todas las transacciones que se hicieron mientras se hacía el export y el import. Todas esas transacciones las aplico y sincronizo los dos ambientes. Una vez sincronizados los dos ambientes, habilito un failback, o sea, replico de Oracle 12 hacia Oracle 10 o hacia Oracle 11 para no perder ninguna transacción que realice en 12. Una vez tengo listo el failback, entonces ya puedo mover los usuarios de producción al nuevo producción. Ese momento de mover los usuarios es el único periodo de tiempo donde la base de datos no está disponible, y depende lo que me demore moviendo los usuarios, 5 minutos, 1 hora, pero una ventana de mantenimiento se reduce dramáticamente con una herramienta como SharePlex, ¿sí? Porque todo el tiempo la base de datos estuvo disponible. Y si algo falla en la migración, yo puedo regresar a los usuarios porque todas las transacciones que se hicieron en Oracle 12 se replicaron hacia Oracle 10. Entonces puedo mantener los dos ambientes en paralelo y hacer esas migraciones sin afectar a los usuarios. Entonces, ya para finalizar, pues Toad soporta el ciclo de la vida de la base de datos, el ciclo completo, la comunicación entre lo que es desarrollo y administración de base de datos. Ese conflicto entre las dos áreas de trabajo pues ya no se presenta. Ustedes ven que todo se maneja con reportes, hacia una metodología de mejores prácticas. Foglight es nuestra herramienta de monitoreo desatendido 7x24, de monitoreo sin agentes, perdón, para diferentes versiones de base de datos, y todo consolidado en una ventana. Y SharePlex nos permite replicar de Oracle hacia Oracle y en sentido contrario, de Oracle hacia SQL Server y en sentido contrario, o de Oracle específicamente a Teradata, hacia Postgres, hacia HANA. ¿Sí? Se va a hacer algún tipo de migración de Oracle hacia esos ambientes. SharePlex tiene diferentes casos de uso, no solamente migración, también alta disponibilidad. O sea, con SharePlex ustedes pueden habilitar un sitio alterno para alta disponibilidad. Pueden habilitar un sitio alterno para reportes. Entonces, normalmente las compañías tienen su sitio de producción y su sitio alterno. En el sitio alterno pueden tener DataGuard, por ejemplo. Eso significa que la base de datos está mount, pero no está operativa, solamente está mount. Y toda esa infraestructura en la que invirtieron, que normalmente es un servidor idéntico al de producción, no se está utilizando. Con una herramienta como SharePlex pueden habilitar esa base de datos para que esté open y puedan hacer transacciones o consultas sobre esa base de datos. Pues se identifica por todo este tipo de soluciones que están orientadas a maximizar el tiempo, ¿no? Tanto mejores prácticas en desarrollo como maximizar el tiempo de los DBAs. Les dejo mi correo electrónico, germán.ordones@quest. Cualquier duda que tengan, con mucho gusto. No tengo tarjetas en este momento, pero si anotan mi correo electrónico, yo estoy atento a responder cualquier inquietud. Así que muchas gracias por su tiempo y continuamos entonces en el OTN en otras sesiones. Muchas gracias. Hay un canal de nosotros que es Infopar, está afuera. Nosotros vamos a estar ahí si tienen ustedes dudas. Y también tenemos encuestas y rifas que vamos a hacer en el stand de Infopar. Muchas gracias.
Hola, buenas tardes a todos. Ahí atrás, bajando un poco las escaleras, está un food truck para que ustedes puedan comer algo, descansar un ratito y a las 1 empezamos de vuelta en punto. Vamos a tratar de iniciar ahora, si no se nos enciman las charlas. Muchísimas gracias.
Sí. Good afternoon. Thank you very much for coming. Thank you very much for the invitation. I have two presentations I'm doing today. Both of them have more slides than I will be able to cover in the time that's available. But hopefully you will download those presentations and get yourself up to speed with any of the additional contents. And then if you have questions, feel free to send me emails, and I would be very, very happy to respond to your emails. And if you want, send them in Spanish. They don't have to be translated into English. I just will only speak English when I'm on a stage because it's too easy for someone like myself to use the wrong word. So I stay in English when I do presentations for Oracle. I have an unsafe harbor statement, unlike the Oracle people who have to say, don't hold us responsible. I have never worked for Oracle. You can hold me responsible for what I say. If I talk about something, it's real, and it's something that we have done if it's anything technical. This presentation is not very technical. My next one later this afternoon is a lot of code. It's intended for people who want to start doing application things, application PDBs in Oracle 12.2, and is intended to prepare you for Oracle 18. If you don't know, Oracle 18 will be released at Open World this year. So no 13, no 14, no 15. So I'm going to skip over my introduction very quickly. Hopefully everyone has some familiarity with who I am, and if not, who I am is not all that important. But I used to be an Oracle ACE director. I've now left that program because my travels and my work have consumed too much of my time. You may have also run into my website. I have more Oracle code, I think, than even Oracle has, because I make sure my demos work. I work for a company, and I normally keep this in here just for people who care, and I'm just going to skip over the company and what we do. Most of my work is around Oracle stability. It's about security. We're the second largest security integrator in North America. A lot of very large databases. A lot of my projects have been in petabyte databases. So I left terabytes behind in 2012. Performance tuning, data migrations, and now a huge amount of Oracle Cloud. So what I want to talk about today is really three separate presentations, all put together, hopefully about 15 minutes for each one. The first one is I want to criticize Oracle Corporation. And if there's anybody from Oracle in the room, please don't panic. It will end well. But we need to be honest. And part of the reason that I do this is that Oracle has done a horrible job of talking to Oracle DBAs about the Oracle Cloud. DBAs should be running to get the Oracle Cloud. And most DBAs I know don't want anything to do with the Oracle Cloud. And it's not because of the DBAs, it's because Oracle has given the wrong information and given it very, very badly. So there is nothing wrong with the cloud. Your life will get much better with the Oracle Cloud, but you won't learn that from Oracle. So I want to talk about that. This is Oracle Open World last year. Larry Ellison, fully managed by Oracle. It's not true. This statement is completely not true. But if I was a DBA who was worried about losing my job, that would really bother me if Larry Ellison is saying, Oracle's going to manage this, you don't have to anymore. We don't need you. It's worse than that, because just before Open World, those of us who were Oracle ACE directors had a private briefing in Redwood Shores at Oracle headquarters. And this says, managed by Oracle, no customer DBA required. That was basically telling a room full of DBAs, we don't need you anymore. You aren't going to have a job. Maybe you should learn how to say, do you want cream with your coffee? Do you want fries with that? 100 people are sitting in the room when he did this, and about 90 of them immediately said, there's no way I'm going to help my company or my customers go to the Oracle Cloud. It's not true. And that's why I say I'm going to criticize Oracle, that is absolutely not true. And I will prove to you that it's not true. And why you need to be thinking about what the cloud can do for you and not what Oracle people are saying about their product. If you drive trucks or cars, you are going to lose your job. We aren't going to need you in another 10 or 20 years. But if you're an Oracle DBA, the cloud will have very little effect on your job except to make it better. I'll prove it. If you put your databases into the Oracle Cloud, is Oracle going to rack and stack the hardware? Of course not. It's in their data center. If you put your database in the Oracle Cloud, is Oracle going to provide all the network connectivity? Is it their firewall, their NTP, their DNS? Are they the ones that provide security for the data center? Of course they do. It's their data center. But is Oracle going to install your applications for you? No. When you buy a subscription in the Oracle Cloud, you pay based on the amount of CPU. That's it. How much storage, how much CPU. If I buy a little tiny bit of storage and a little bit of CPU, I pay less. If I buy a lot of storage, a lot of CPU, I pay more. But suppose I want to release my application every week. Somebody else wants to release their application twice a year. Upgrade it, patch it. Is Oracle going to do this for the same price? Can I pick up the phone and call Oracle or open an SR and say, we just hired 10 people. We'd like you to create new user accounts? No, it's never going to happen. Not for a fixed subscription price. So when they say fully managed by Oracle, that is not true. When they say Oracle DBA is not required, I'm sorry, Oracle, it's not true. All of these things require DBAs. You go into the Oracle Cloud and you have performance problems, you cannot open an SR and expect someone from Oracle to tune your application code. It's not going to ever happen. Certainly not in the next 20 years. So those messages that Oracle's been giving out are not just wrong, they are completely misleading. Oracle's history has been one of embracing Oracle DBAs. Oracle's first product was the database. Oracle's first customers became the first Oracle DBAs. This is a slide that I got from Tom Kite many, many years ago, talking about how important DBAs were to Oracle Company. It's still true. The cloud does not change that. So, if you look at the history of computing with all computing, starting in probably the 1960s when I got into it, 1970s, and going up through all of the changes that we have had. From the time that we had Oracle, and my very first Oracle was on an IBM mainframe. It was an IBM 370-145. All of these things have caused changes in our industry. If you wanted a job today working Oracle on mainframe, there are no jobs. If you wanted an Oracle job today doing client server, maybe working on a VAX, there are no jobs. We have all had to evolve over the years our skill set. But today there are more DBAs working more hours than there have ever been before. Every time we've had a change, it's resulted in more, not less. And we will see the same kind of changes happening again. The other thing I want to bring to your attention is that pretty much every time Oracle has made changes to our product, we have rejected them initially. I've been in Oracle so long, I remember rollback segments. I don't know how many of you remember them. They were horrible. Oracle replaced it with the undo table space. When Oracle did that, my colleagues and I all said, this is horrible. We need rollback segments. Today, nobody would want rollback segments. You can still use them. They're still fully supported. Nobody is using them. The same thing with ASM. We heard lots of screaming and yelling and negative feelings about ASM, replacing Veritas, replacing raw disk, replacing file systems. Nobody would give up ASM today. OEM, every single time Oracle has changed our technology, we have been unhappy at first, and then we wouldn't give it up. If you have an Exadata, would you give up your Exadata to go back to a pizza box? I don't think so. You would not replace your Exadata with a 3U server or a 5U server. You know you wouldn't get the performance. So Oracle's cloud is providing us as DBAs with something that we cannot get anyplace else. One of the reasons why Oracle ODA, the ODA, and the Exadata, and some of the other Oracle engineered systems are so effective and why we like them so much is because Oracle engineered them. When you move Oracle databases into the Oracle Cloud, Oracle engineered the entire data center. Not just the server, but the networking and the storage and the DNS and the NTP and the firewall and everything else. It's not some architect who never read an Oracle document or a system administrator who never read an Oracle document making decisions. It's Oracle engineering the entire data center, the entire tech stack. And what it means from a DBA standpoint, for those people who I've worked with going to the Oracle Cloud, is that they're not having to work as many hours, they're not having as many outages, they're not having to spend nearly as much time doing performance tuning or doing fixing issues with stability. So from a DBA standpoint, having a completely Oracle engineered technology stack has made their life as a DBA better. And it's why I say, if you ignore what Oracle says about their cloud and you look at the reality, it improves the quality of our lives a lot. The second piece of my presentation I want to do is something that I want you to understand, something which we normally don't talk about as DBAs. And it's why our management at the companies or the organizations we work for are going to go to the cloud. Why it is inevitable and why it cannot be resisted. And this is a presentation that I primarily do for IT management rather than for DBAs, but I think it's important for DBAs to get this information so that you understand what's going on in our industry. There are only two things that matter in IT: quality of service, total cost of ownership. Am I getting the quality that I need? Am I getting it for a price that I can afford? So when we talk about quality of service, is the IT solution stable? Is it secure? Can it scale to handle the workloads? Total cost of ownership, I think everybody understands what that's all about. They don't like paying money for what we do. We're in the middle of a change to our industry that happens every 20 years. And it's so far, in my lifetime, this is going to be the third time. It has always been about 20 years. So we started off in IT saying, we are the technology leaders. We're great, we're wonderful, we're on the cutting edge. But it's not true in a lot of places. We're terrible at automation. We are terrible at buying things when we need them. When we buy a server for what we think we need in 2 years. When we buy a server, or when we buy licenses, we buy for the peak period that may only happen at Christmas time, when people do a lot of shopping online. We don't buy for what we need at 2 o'clock in the morning, 3 o'clock in the morning, 4 o'clock in the morning, Sunday when everyone's at church. Manufacturing people have been doing this now for a very, very long time. And a lot of what's going on in the cloud, a lot of the financial push, is that we in IT have finally figured out what Henry Ford did in 1908. So in the 1960s, we ran all of our applications on mainframes. The data was on the mainframe, the application was on the mainframe, and the quality of service was terrible. In the 1980s, we went to client server. That's when Informix, Sybase, and Oracle first showed up. The applications were sitting on Windows desktops all over the planet. Hard to maintain, hard to patch, hard to upgrade and migrate. 20 years, so there's 20 years, 20 to 60 to 80, another 20 years later, we went to application servers and web servers. And management of organizations and financial people are complaining. We don't get the quality of service that we need. It's costing too much money, too many outages, too much breakage. So what we are doing right now, at about 2020, 2.5 years from now, is that we are looking at DevOps and the cloud as being that next generation, trying to solve the problem of more stable, more secure, more scalable, keeping the costs under control. We learned lessons from mainframe computing. We learned lessons from client server. We learned lessons from app servers, web servers, and n-tiered architecture. And as we've moved our way through this progression, where we are going now is what we call DevOps. But as DBAs, what you want to be focusing on is that what this is just-in-time procurement of resources. And I'll show you how big the impact is and what Oracle is telling your management and what people like I am telling to your management. We've been doing infrastructure as code, as Oracle DBAs for a very long time. I remember in Oracle 6, I was working with response files. We would install the database, we would save a response file, and then you could replay the response file to build the exact same database over and over again and know that you'd get it perfect. So we have response files like this that you can still make with the Oracle database today, and you'll be able to make, as far as we know, forever into the future. Oracle also has a product called SiteGuard, which again does infrastructure as code, where you're scripting it out, in this case as shell scripts, and then running the shell scripts to repeatedly do a particular piece of work. So the business case is, if I do a response file, I write it once, it always works the same way. It reduces my cost, it reduces my risk, and it works much faster than having somebody in OUI or DBCA click, 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 maybe getting it wrong. Here's the argument that we're making to your management, and this is what you want to be aware of. Oracle's got multiple clouds. What Oracle calls IaaS, Infrastructure as a service is generation 1, and it will not be enhanced in the future. What Oracle calls PaaS, Platform as Service, may or may not be enhanced in the future. What you want to focus on is the Oracle Bare Metal Cloud. And here's part of the reason. Part of it is that you can do fixed price subscriptions. Part of it is that you can use what's called a metered subscription. Here's the numbers that Oracle has published on their website. 7.5 US cents per CPU hour. People who are used to buying $1 million worth of hardware and licenses have a hard time not wanting to spend 7.5 cents per hour for block storage, or 15 cents for dense I/O compute capacity. It's a staggeringly large savings. Part of the reason for looking at infrastructure as code and looking at the Oracle Bare Metal Cloud's ability to do metered service is that normally when I go to the cloud, if you go to the Amazon cloud or you go to the Azure cloud or the Google cloud, you have to buy your Oracle licenses and you have to pay for the hardware subscription from them. So let's say you want 16 CPUs for your workload on your database. At midnight, you pay for 16 CPUs. At 4 o'clock in the morning, you pay for 16 CPUs. Every day, whether you're using it or not, you pay all the licensing, all the hardware, everything for 16 CPUs. If you go to the Oracle Bare Metal Cloud, you can say, I don't have anybody connecting to my database until 7 o'clock in the morning. I'm going to have only 2 CPUs so that our man can run. Or so if one person wants to run a query, there's enough CPU for that one query or 2 queries. My employees come into work between 7 and 8 o'clock in the morning over on the East Coast. I'm going to pay Oracle for 6 CPUs from 7 o'clock to 8 o'clock. I'll pay for a total of 8 from here, 12. I'll get up to 16 CPUs when I need it. When my people go to lunch between 12 noon and 1 o'clock, I'm going to pay for less CPU. I'll pay for a lot of CPU all afternoon, and then as people go home during the day, I will pay for less CPU until I go back down to this. The difference is significant. Up here, I paid for 384 CPU hours with Amazon or Google or Microsoft. With the Oracle Bare Metal Cloud, I only pay for 176 CPU hours. It is a huge, huge savings. In US dollars, the difference is I save over half the money by buying each hour what I need. And that's what I mean by just-in-time provisioning. Why do you buy more CPU at 2 o'clock in the morning than you need? Buy what you need at 2 o'clock, buy what you need at 7 o'clock, buy what you need at 3 o'clock in the afternoon. If you have a business where you only are open 5 days a week, this is what it would cost to buy all of that CPU hours every single day. You can cut it down by 2/3 by using the Oracle Bare Metal Cloud. And this is not about technology, this is about the cost of ownership, and this is why management will adopt the cloud, is that they don't have to buy things before they need them, and they don't have to pay for them when they're not using them. I ran another comparison just to give you an example of a single Hewlett-Packard server compared to the Oracle Bare Metal Cloud. After 3 years, the costs are almost identical. So why would you go to the cloud? Because for this solution, you also had to spend almost $1 million to buy the Oracle licenses in the first place. They look the same, but here the licenses are included in the subscription. Up here, you have to pay for support, and you still have to buy the licenses. And again, management is not going to spend $1 million with Oracle if there is a way that they cannot spend that money. So, things to think about. I'm going to skip over a few more slides, but I just want you to get a feeling for what people who are in pre-sales and sales are saying when they talk about it. From a technology standpoint, you're better off in an Oracle engineered stack. From a financial standpoint, your management's better off only buying what they need. If you buy Oracle servers or anybody's servers and you don't need them, you can never give them back. If you buy more Oracle licenses than you need, you cannot give back what you purchased. With the Oracle Cloud, if you aren't using it, you just give it back to them and you stop paying. So the last part of my presentation, I'll be about 10 more minutes, try to help get us back on track time-wise. As I want to talk to you about how you can implement disaster recovery almost for free in the Oracle Cloud. And this is only possible in the Oracle Bare Metal Cloud, and it's only possible because of metered service. How many of you have a separate disaster recovery data center? One person, two people in the room. In the United States, it's a little bit higher, but almost nobody has a DR site because they're very, very expensive. And yet, everybody, when you talk to DBAs or you talk to IT management, says, we know we need one, but it's really expensive. So I'm going to teach everyone in the room in the next 5 to 7 minutes how you can set up disaster recovery for your company almost for free. It's not completely free, but it's really, really close. So we all know that we need DR. We all know why we need DR. I don't have to tell anyone in this room about that. We also know that Oracle, to help cut the cost of disaster recovery sites, has invented ways that we can get more value out of having DR. We can use our DR for backups. We can offload reporting using Active Data Guard, which costs us more money for the Active Data Guard licenses. We can move our development and QA over. But ultimately, it's still far too expensive for most people to have DR sites. Here's the concept that I want you to walk away from this presentation with. Think about the fact that with the Oracle Bare Metal Cloud, you only pay for what you use. Now, if you have a disaster recovery site and you aren't having a disaster, maybe you could not be paying anything or very close to not anything. So let me show you how. If I subscribe to the Bare Metal Cloud metered service, it means that I pay for what I use, I don't pay for what I don't use for CPU. I deploy my web servers into the Bare Metal Cloud, and then I shut them down. I build Apache, I build JBoss, I build whatever it is I want to build, and I shut the servers down. The only thing I pay for is storage. I put my application servers into the Oracle Bare Metal Cloud. As soon as I have it installed and tested, I shut it down. I pay nothing except the storage for WebLogic or WebSphere or IIS or whatever technology I have for my app servers and web servers. So my whole application stack is over there, and I'm only paying for storage. Now, I deploy my database to the Bare Metal Cloud, but I only enable 2 CPUs. Why? Because I'm going to use Physical Data Guard to do redo apply. Even if my application runs with 64 CPUs, I only need 2 to run redo apply in Physical Data Guard. So again, my cost is very little. I bought no hardware, I paid for no licenses, I subscribed to 2 CPUs. And now I have a DR site, and it costs me next to nothing. Let's take a look at what it would be like to build this. If I do a normal disaster recovery, I buy all of this for my on-premise production, and then I have to buy all of this again, double the hardware, double the licensing to set up my DR site. So if I fail over, everything works the same. And I pay for all this licensing and hardware even if I never ever use it. Now, let's look at it from the standpoint of using the bare metal cloud for DR. I still have to have, or I may have already purchased, my primary production site. But now, I want to have DR and use the bare metal cloud. Oracle provides all of this infrastructure. Oracle provides all the networking hardware. What do I pay for? I pay for my web servers, install them, shut it down. I pay for my application server, install the app server, shut it down. My database server, I install Oracle Database. I have to pay for my storage. I probably want to pay for OEM and the ability to do my backups. But that's hardly any cost because I'm paying for only minimal CPU. On an ongoing basis, I don't have to pay for any of this. I only pay for the minimum CPUs, the storage, and maybe for having OEM running. That's it. So a DR site that might cost millions and millions of dollars, essentially you can have for a few $1,000s a month. It's a staggeringly large savings, and it's only possible in the Oracle Bare Metal Cloud. So, my presentation's about the Oracle Bare Metal Cloud. It's the easiest thing to talk about in 60 seconds. Bare Metal Cloud means it's an Oracle public cloud, but the servers are bare metal. You can install your own operating system. You can install your own database. If you don't like Oracle database, you can install SQL Server or Mongo or MySQL. It's your server. That is what's critically important. It is just physical storage and physical servers, and you are installing on bare metal. So it's yours and you can do whatever you want with it. There is the ability to do virtualization too, but ultimately you can have your own physical server. So this is what the Oracle bare metal server stack looks like. These are all Sun Intel boxes. And you can read this information on your own, but again, I want to finish very quickly here to help get the schedule going again. But I really, really encourage you, from the standpoint of the quality of your life as a DBA, look at the bare metal cloud. From the standpoint of helping your management save money, look at the bare metal cloud. From the standpoint of being able to do something you cannot afford today, which is set up a DR site, bare metal cloud again. And with that, I'm going to wrap up, and thank you very much. So if you're worried about your future as an Oracle DBA, stop listening to Oracle. Look at the services. Look at how they're pricing it. You will be better off career-wise in the Oracle bare metal cloud than you are right now. Absolutely. From my experience working with my customers, I haven't had a DBA who has said, oh, this is horrible, I want to go back to the way things used to be. Not one has ever said they want to go the other direction. With that, I'd want to thank our translator, Carolyn, who is up in the booth behind us. I hope she has done a wonderful job, and I'm sure she has done a wonderful job translating what I'm saying so that you can understand. And I always thank my translators. They are doing a wonderful job, and they might be amazed that I can write SQL and C, and I'm amazed that they can hear English and simultaneously speak any language, and especially a language other than English. So thank you, Carolyn. Thank you, everyone. I appreciate your invitation to come, and I look forward to talking to you again later today. Thank you.
Buenas tardes. Creo que eso fue el señal para empezar. Okay, thank you. So, welcome to this presentation about serverless architectures. This guy always looks like a composer when I see this photo. Anybody knows him? No. I think you all know what he did, but probably very few could now tell his name. He's a German guy. He grew up in Munich, where I grew up. He had his youth he spent in the mountains without electricity, no internet. He's too old for internet. Then he came back to Munich and he studied at the university, computer science. He became rich, I tell you this later. He went to the US and he met the two guys from Google when Google was still in a garage with a couple of PCs. And they met at a party and he said, well, here, have a check for $500,000 US and tell me in 6 weeks or in 6 months, I think, how you're doing. And then 6 months later, they talked again. His name is Andy von Bechtoldsheim. He's the founder of Sun Microsystems, the company that built the service that was bought by Oracle. And he's actually a very technical guy, somebody who dedicated his whole life to building server machines. Now, this talk is about serverless architectures, about cloud. What do you think this guy is thinking about cloud computing? Or So he dedicated his life for building Sun servers, and now we say, well, just go serverless, you don't need a server anymore. You'd be surprised. He basically says if you're a startup today and you're not going to the cloud, you're doing something very, very stupid. And this quote, you can tell by the wording. I mean, he's not a native speaker, same as me. You can tell it's a little bit older, this quote. But for the startups, even the guy who founded the company that builds all the cool servers in the world says, if you're not going to the cloud, you're making a big mistake. So my name is Frank, I'm from Germany. I work in middleware, I do cloud computing. I wrote a book about cloud computing, this one in 2011. If you think back, what was your opinion about cloud computing in 2011? A lot of people thought it's more a marketing gag. No, it's nothing really important. It will go away, it will never be serious. I work in middleware, I wrote another book about WebLogic. And usually I'm working across Europe. I spend a year working in Australia. I'm an Oracle ACE director that makes it possible to travel to places like Paraguay. And yeah, I'm going to give you this presentation about serverless architecture. So remember from the slide from Andy von Bechtoldsheim is his name, that for the startup, probably the only solution is cloud computing, or the only, well, solution that makes sense. Now, I wrote this book in 2011, and since then a lot of people told me and said, you know, Frank, that's okay for the startups, it's okay for training, it's okay for testing maybe the cloud, but a big company, why would they give up their data center and move to the cloud? This will not happen. So 2011, I kept hearing this since 6 years. And if you hear this over and over and over and over again for 6 years, you start to believe it. So I thought, why would a big company give up its data centers? And what happened? Well, end of last year, early this year, I like to call it the ketchup bottle effect. Do you know what this is? You open a ketchup bottle and you want to put some ketchup on your fries, but there's no ketchup coming out of the bottle. So you shake and there's no ketchup coming, and all of a sudden all the ketchup is coming. I think right now, we are exactly at this situation in cloud computing. This is a company I worked for, which has a slightly traditional image in IT. So everyone thinks like, well, German railway, yeah, but they're not the coolest company for IT. But you know, they're everywhere in Germany. They have to run the trains, they have to sell tickets. The train stays don't stop at the border. They have to move to France, Italy, Spain, and so on. So they're connected. It's not easy IT that they run, and it will be customer data, they will have security issues, and guess what happened? they went to the cloud. Well, they're going to the cloud right now. They have 2 data centers. I was doing another project for them in middleware. And last year, they decided to not renew the contracts for their data center, but to move to the cloud 100%. And I was actually working in the same office as their chief architect, and every single phone call he was doing was about cloud migration. I skipped this slide. The talk is about fast function as a service, and it's a technology that was announced by Oracle last year at Open World. And you know, there's an internal joke for Oracle, and people say, if it was announced twice at Open World, at the big conference, then you will see it as a product. So it was announced 2016. I think they will announce it again this year, and then we will see it. So many examples that I bring you here, they're not from Oracle, they're actually from Amazon. So you think like, why should I listen to Amazon examples if I come to an Oracle conference? I don't think I need to excuse myself. I think the future will be multi-cloud anyway. So this company, they have Oracle products, they will go to the Oracle cloud, but they use other clouds as well. Okay, so talking about cloud computing and explaining this serverless and function as a service, it helps a lot if we have a very good understanding of cloud computing, and then the rest is kind of easy. Then you will say, well, now I understand what serverless and what function as a service does. So talking about cloud computing, what do we need? The first thing is we need an API. That's most important. And there's many consultants, many speakers walking around and talking about, you know, API gateways, API management. But the core thing for a cloud is an API. If I say API, typically what you think is some JSON structure that we send to the cloud, and then there will be some resources created. And that's not wrong. That's actually correct, no? But it's only one out of 4 things that we really need if we talk about API. The second thing is like a web front end for the API. It's also a good thing to kind of evaluate your cloud. How good is the web front end? How easy is it to work with it? This is very often actually where Azure from Microsoft gets a lot of credit. You know, everyone says, you know, maybe it's not the best cloud, but I like the front end. I like the way how to work with them. This is the AWS example. This is the Oracle Cloud example for the Oracle Cloud Console. But then not everything is just the web front end. We need the command line. The other thing, that's the Amazon command line to find out the regions that exist for this cloud, and it will just output all the regions in a table. Anybody knows how to do the same with the Oracle Cloud, with the command line? Ah, you don't. You see, this is one of the problems of the Oracle Cloud. You should know this, I should know this. I at least know where to look it up. This is where you can go to download the command line tool and to try the same thing with the Oracle Cloud. So we have the technical API, the JSON structure, we have the web front end, we have the command line. What else do we need if we talk about APIs? I assume some of you are developers. You don't want to program against the JSON structure, you want some language bindings, some SDK. So these are all the language bindings we can get for AWS, and there are language bindings for the Oracle Cloud as well. And those 4 things together, this is what I want to think about if we talk about API. So API is the first core block, the first core thing we really need if we talk about cloud computing. No API, no cloud in my opinion. And that's the big difference. Sometimes people say, I have a friend, he wrote a book, and in this book about cloud computing, he put a quote that says, you know, there is no cloud, it's just somebody else's computer. That's kind of funny, but it's not the real story, because if you outsource your IT, you run it on somebody else's computer for 2 or 3 years, but you don't get this, you don't get the API. So the API is the key differentiator. What else do we need for cloud? We need elasticity. Agree? I hope you agree. I brought you the 2 most beautiful graphs you will ever see regarding elasticity. If you've seen them, forever you will remember what I mean with elasticity. First one comes from Netflix. What you see on the top is business. What you see on the bottom is technology. What you see on the top is the number of videos they stream throughout a week or a couple of days. And what you see here is the number of cloud instances that they provision. And if you overlay those 2 curves, they almost exactly match. And that's fantastic. That's as good as it gets. If you scale down here, you stop instances, so you spend less money. If you have more business, you need to scale up. But then again, you make more money because you have more business. And this match is like really, really beautiful. There's apparently a small group inside Netflix working on, it's not one rule that defines the scaling. So the scaling is done based on rules. But it's not one simple rule. It's like dozens of rules that together make this scaling possible. And there's like 5 or 6 people defining those rules. You like the idea? Good or not? Usually IT people say, yeah, that's not bad. If I tell this to a good friend of mine who's working in medicine, he would say, really? Do you have 5 people defining a more or less simple sine curve? You could do this easily. Just take a formula for a sine curve with the 2 open parameters, fit the parameters, and maybe kick it a little bit on the left-hand side to get this bent. And that's it. You can model it. You don't need dozens of auto-scaling rules and 5 people that create those rules and then scale because of those rules. I'll show you something else. Another curve, system load. Can you guess what is creating this load? It's something really interesting. It happens 2 weeks before Christmas. This is Christmas. It never happens at Christmas. There is peak for summer holidays. It also happens on Mondays. Look at this, Monday, 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 Monday. And it's a peak for April Fool, double peak for spring break. What do you think it is? It's not a rhetoric question. Do you have any answers? Flights is a good answer. I can't see you, but I hear a male voice, and I tell you what. Typically, the male answer to this problem is flights is very good. Somebody else said car bookings. That's also very good. Any lady, any woman that would like to guess? Usually, women guess much better in this than men. Shoe sales? Well, that's Stuart, you don't really count as a woman, but shoe sales is a good guess. Now, honestly, this is the statistical thing about causation and correlation. Many things correlate to this curve, but only one thing is really causing it. So it's honestly hard to guess. The best guess that I ever had, it came from a woman, and she said, maybe chocolate consumption. I said, well, it's not really chocolate consumption, but chocolate consumption is highly related to this. I tell you what it is. There was somebody tracking 1 million Facebook users, and they looked at their status, and they looked at status changes from I'm in a relationship to it's problematic, or I'm in a relationship to I'm single. So this is when, well, when relationships break, like 2 weeks before Christmas, summer holidays, if you have spent time together, a spring break, this double peak, in my opinion, this is when it happens, and this is when people talk about it. And when the status change happens, they recorded this as a status change. And that's exactly the load that the online dating portal site will see, like, you know, Tinder, whatever you have here in Paraguay. I don't know. This curve, you cannot model with a simple function. If you know it from last year, you could kind of predict it. If you tell me when spring break is, I could tell you, well, there will be this double peak again. So this is where you really need those auto-scaling rules, where you expect your system to have elasticity to scale up and scale down quickly. Why? Because otherwise you had to plan for this huge peak and had to provision your hardware for this huge peak. Now we have APIs, elasticity, and the third thing, people always think it's very boring. It's this pay-per-use. What does pay-per-use mean? Well, you go to the Oracle pricing website and you find out that it will cost you, this small instance without even local disk will cost you like $7.5 cents. And people think, yeah, this is the pay-per-use, isn't it? But I tell you, there's much, much more behind. There's actually this included. So somewhere right now there is a big boat doing what? Well, putting cables on the ocean floor and connecting those dots. Those dots are the data centers from the Google Cloud, and they're connecting, you know, Singapore with Sydney, with Sao Paulo, and San Francisco. And remember the $7.5 cents, the cables are included. And the other thing is all those dots are included. This is where the data centers are, and this is the really amazing thing. One of my most popular, most favorite definition of cloud computing is that all of a sudden, if you start with a cloud account, you own a massively parallel, distributed, and highly available supercomputer with linear costs. It sounds very scientific. I spent a lot of time in university. But this is it. This is what you get. And from a computer science view, it doesn't get any better than this. This is really pure joy. This is beautiful. This is as good as it gets. Why? Because actually it means if you have a problem and you need such a compute instance for 100 hours because it's a big problem, you could do the same thing for the same amount of money by running 100 instances just for 1 hour. What would your boss prefer if you spend 100 hours or 1 hour for the same amount of money? So, in my opinion, cloud computing is a little bit making use of this parallelism and of this high availability that you automatically get from the cloud, and a lot of people tend to forget this. Many years ago, a friend of mine who was actually running a big software company with 1,000 people, after I wrote this book, he said, "But Frank, what's the big difference of running software in the cloud or running software on-premise? It's basically the same software. Where's the big challenge?" You know, the big challenge is making good use of this. The other thing is your IT resources are not fixed anymore. You can just scale it up and down. I had a project where we spent tens of thousands of euros just deciding what kind of hardware we would eventually need in 1 year. If you have the scalability, you can stop thinking about this. So we have APIs, elasticity, pay-per-use, and at the end we get a fully programmable data center. That's the point. Now I want to talk about this. Monte Cervino, most beautiful mountain we have in the in the Swiss Alps. And we actually talk about the summit, the best thing, the highest point of this mountain. Why? I want to bother you a little bit with this NIST definition, you know, infrastructure for service, platform as a service. But we want to look at this from a different angle. You all know infrastructure as a service, and you can tell that I'm a big fan of it. It's like Oracle bare metal that Dan was talking about here in the previous presentation. And what we want to check is for API, elasticity, and pay-per-use. Now APIs, we have them all the time, so we don't really check for APIs anymore. But we want to know about elasticity and pay-per-use. Elasticity for infrastructure as a service, we have it. We can scale servers up and down. It's possible. It's not easy if you do it on the command line for AWS. It's like 4 lines. You need to scale, define auto-scaling groups and scaling events and so on. So it's possible, but not easy to do. How about the pay-per-use? Well, it's the $7.5 cents that I was talking about. So it's all done. We all have these 3 criteria for cloud computing. Looking at PaaS, it's a little bit different. We have scalability, and actually the scalability gets easier because it's PaaS, it's platform. You don't specify servers, you specify the PaaS. How about the pricing? Well, typically for those PaaS systems, you don't pay for them, you just pay for the underlying infrastructure. Now we have those container services all of a sudden that let you run Docker containers. Same story. Can you scale? Yes, you can scale. That's possible. It's not very difficult. We can scale them. And the pricing is, again, you don't pay for the container service, but you pay for the underlying infrastructure. Now I have to confess you something. This pay-per-use, it's a big lie. It just doesn't work like this. I was running a workshop in Europe. I think it was in Italy, and then I had to dash off and go home. And we had 2 weeks of vacation. We went scuba diving. And I came back from scuba diving, and then I realized that I didn't stop some instances on the Amazon cloud. I didn't use them. I was 2 weeks away for scuba diving. I thought it's pay per use, you know, pay per hour per server. But it's not pay per use, it's pay per hour that you provision the service. So I got a huge bill after 2 weeks. I had to pay $80 for a server for a couple of servers that I never used. So this pay per use, what we say is not pay per use because I didn't use it. It's pay per hour provisioned. Now the solution is the new thing. It's the FaaS, function as a service. We don't know the name of the Oracle product yet. It will be out soon, I guess. And the new thing is it's really pay-per-use because you run a function as a service and you only pay if you call the function. And the other thing is the scaling, how you define scaling for it. There is no dial, no configuration for scaling. It just scales. It scales up and down. If you use it more, it scales more. If you use it less, it scales less. So this is kind of as easy as it gets, and it's also, because you only pay when you use it, it's also as cheap as it gets. And I want to explain this a little bit more. Yes? Pardon? Well, we never know the names before it's officially out. Usually there's a briefing at Open World for the ACE directors, and then some product manager comes and says, tomorrow it will be officially announced, and we think this will be the name, but it's not decided yet because Larry Ellison himself will decide about the name. This is typically what happens with Oracle products. So let me talk about serverless, and also let me talk about function as a service. Now the name serverless is not really good. I told you about this friend of mine who's a doctor who wouldn't like the sine curve with done by 6 people, who would say, I can model this. The same friend says, whatever you have, if you come to my office, even if you have like green spots on your skin on your left-hand side, I have a good Latin name for it. Whatever your disease is, I can give you a good Latin name for it. In IT, it doesn't work like this. In IT, we like cool-sounding, marketing-driven, fluffy names. So this is why serverless at the end looks like this. A lot of people say, well, serverless, are there really servers behind serverless? And the short answer is yes, it's just a really, really bad name. Serverless was announced by Amazon in 2014, and it's a product that is called Lambda, and they said it's serverless. So for them, it's a synonym. Serverless and function as a service is a synonym, but technically it's function as a service. Why? Because we run a function as a service. Now, if you think about serverless in a broader sense, like many things are serverless. Actually, all PaaS, all platform as a service is serverless. Why? Because this is the thing about PaaS. Now, you provision a platform, but you don't care about the underlying infrastructure as a service. So serverless in a broader sense, in quotation marks, all PaaS, in my opinion, is more or less serverless. So at the end, if you're really precise, the cool thing is FaaS, function as a service, and not serverless in a broader sense. Amazon is using it as a synonym, so for them, it's the same. Now, Adrian Cograft, the guy who was running Netflix, he says, if you have something, people often bring the database example and say, I have my database running, and you can send me some SQL statement, and I quickly execute it. Does it count as serverless? No, because it's there all the time. It's there, it's running, it's hours provisioned, and then you pay for those hours provisioned. And Mr. Cograft says, if you can spin it up quickly and then shut it down and you stop paying for it, then just call it serverless or call it FaaS. He's Amazon. This is why he uses serverless as a synonym for FaaS. I give you a short example for serverless in a broader sense. There's this Amazon service. It's called S3, Simple Storage Service. And it gives you blob storage. You can store a blob, some binary data with a key, and you just say put key and binary data, and then it's stored. Sounds simple, no? At the same time, you get a REST interface. Remember the 14 different locations that we can see in the Amazon cloud? You can decide in the API where you want to store it. So you choose the location. That's pretty cool, no? If you put it, it's replicated 3 times. So if you wanted to build a service yourself, you store the data, and then you have to replicate it across 3 different data centers. And this gives you a pretty good availability. This is the probability that you can access your data, that the access won't fail because the servers are down, which is okay, it's not perfect, 4 nines. And the durability here is 11 nines. That's incredibly good. That's the probability that your data stays intact, that it won't be corrupted. So there's actually no chance that the data will be corrupted in our lifetime. And these are not marketing numbers. There is a computer science paper behind those numbers, and you can read it and understand why they think it's like 11 nines. It's this incredible durability. Now remember, I told you it has a REST interface, so you can put the data with a HTTP put. You can get the data with a HTTP get. If you execute the get and you put 2 blobs to, well, the blobs could be files. This get could get you this, so at the end you get a website back. That's what I did. Now I'm not connected to the Wi-Fi, but if you click on the URL in the slides, you get to this website. And it's actually pretty cool because I never provisioned storage. I never started a server. You could say, well, you access the server because of the HTTP URL. Well, you don't really know. Remember, it's like 3 different servers in 3 data centers. So you're probably more accessing a load balancer than a real server. So even in the URL, you couldn't argue it's a server. It's probably a load balancer or some magic routing mesh or whatever. We don't know. So this is like serverless in a broader sense. No web server. That's pretty cool, no? I have a website, but I have no web server. I think it's amazing. I was running middleware operations for BMW in Germany for a long time ago, but it lasted like 2 years. And we had a group of 10 people, and those 10 people, guess what they did? Well, they installed Apache, they configured Apache, they debugged Apache, they put content on Apache, and they installed and debugged and configured and did the same things with WebLogic. Like 10 people doing this. Where's the web server? Where's the people that run the same thing for S3? You don't really care because, well, you just pay for the service. Now remember, you have this 3 times replication, this incredible durability. You probably think it must be really, really expensive, this service. It's 2 cents per gigabyte. Now this website, much, much smaller than a gigabyte. Remember the WikiLeaks scandal? The whole scandal, the first data they put on WikiLeaks was 2 gigabytes of data. Can you guess how much it will cost? It will cost 4 cents. So all the trouble the guy had because of WikiLeaks was because of 4 cents of data. So this is where you see how incredibly cheap this service is and why it's a cool service. Still, it's only data. So the CTO from Amazon is running his website on S3. But at the end, for us, I'm not a DBA, I'm not a database guy like Dan who was speaking here before. It's just data, no? But if you understand this, you also understand what function as a service means, and this is where I want to get to. So S3 for data is actually the same thing as fast for, well, real code that we want to execute. So how does fast look like? It looks like this. It's literally a box where you can put your code. If you want, you can type it. If you want, you can copy and paste it. Of course, if you want, you can also upload it. But it's a thing that is running your code, and that's it. It could be Java code. It could be Node.js code. It's what you have to do is you have to provide a function. You get an event. This is what is you get called with event data. You can use a context that gives you information about what is running, how long this function is running already, and you can or cannot have a callback to return some data to the caller. And this is it. This is function as a service. Why is it cool? Because if we try to define it, I was trying to kind of split between what really belongs to the definition and what is more characteristic. It's automatic elasticity. You cannot really define how you want to scale it. It just scales. If you have 1,000 requests per second, it will handle them. If you have 1 per week, it will also do it. It's true pay-per-use. If you have 1 request per week, you pay 1 request per week. I will tell you how much it will cost. It's stateless. That's super interesting. So a lot of people say, so what can I do with this function as a service? Could I kind of run my database as function as a service? And the important thing, this is not what it's meant to be. I always try and explain people, I say, this is one additional building block for all the cloud services that you already have. It's not meant to replace WebLogic or the database. In my opinion, I have a development background. It's a bit like a stateless session bean that we used as a facade for a service. No, it's stateless, and this is what it's meant to be. It's event-based. That's the other thing. When I tell you you call this service, you can't even do that. You cannot call this function directly. It will always be triggered by an event. And I need to explain you how you then can trigger this function really. One interesting thing, and that's more characteristic, I don't think it has to be like this, but if you choose to run this function with more memory, you also get more compute power and more I/O bandwidth. That's interesting. This is the way Amazon implements it. And it's using containers. So people say, it's a Docker container then at the end. Well, it's not really a Docker container. It's something like you trigger the function with an event, and then you quickly swap in a container that might or might not be a Docker container. And then if you stop using it, the container might go away. So if you call it next time, maybe there is some little overhead swapping in this container again, or maybe it just works really quickly. But you cannot tell. Different companies already offer this. You get it from Amazon since 2014. There is implementation cloud functions from Google, and there's Azure functions from Microsoft. The cool thing is when it came out in 2014, remember I wrote that book 3 years before, we weren't sitting there and saying, you know, cloud computing is cool, but there's something missing which could be like function as a service. Why is nobody implementing this? It came out and people were kind of surprised. Everyone said like, what are we supposed to do with this? Does it make sense? And then people started evaluating this, and it became a kind of big hype. So I leave you this table for the slides. I don't want to go through all the details. Some tech details. I told you it's triggered by events. If you send an event to something, it's asynchronous. If it's asynchronous and the function for some reason is not working, you want to have a retry, you want to have a dead letter queue. It's like messaging. It's a little bit like JMS or like, you know, I don't know, other messaging systems. The metering is done in 100 milliseconds. That's surprising. So if you use it for 90 milliseconds, you're getting billed for 100. If you use it for 170 milliseconds, you're getting billed for 200. But the increments are in 100 milliseconds. What you're paying, it's the time, and it's also the compute capacity. And the compute power is kind of defined by the memory you assign to your function. If you give it twice the memory, you pay twice as much. If you halve the execution time, you pay half as much. You can set environment variables. The invocation times, they differ, I told you, because the container might be running already or not, but you don't see this. There's no scaling parameter. There's some limitations, like the maximum execution time is 5 minutes. You can start processes and threads, but there is a number of maximum of 1024 processes and threads. This also tells you can do more than just executing a simple Node.js function. You can spawn threads and run processes, so you can do quite a few things. How do you create this Lambda? The answer is, well, you just click on create new Lambda. That's it. That's the thing that is executing, and then you define what is triggering the event. Remember the S3 I told you? If you upload some data, like a web page or some blob data, could be a database backup, it could be up to 5 terabytes, it could be 2 bytes, it could be a small image. The upload could trigger an event. So uploading an event, and this is very often used, like you upload a picture and then the function as a service is creating a thumbnail. If you wondered about how you call the function, if it's only triggered by events, and if you want to really call a Java function, the answer is there can be an API gateway in front. So you call a REST interface on the API gateway triggers an event, and the event is then consumed by the Lambda function, and then you can, but it's not necessary, store your results in a database. So you can test your code. If you test the code, you see the resources it was using, you see the time you were billed, and the real execution time. So this one executed in 3 milliseconds, but I'm billed for 100 because it's the smallest step, and it uses 128 megabytes. That's the smallest amount I can have. That's the image recognition example. There is a small demo in Amazon where you can upload an image, and it then tells you by analyzing the image with some artificial intelligence, you know, this is about food, and this is like a Mexican city probably. So it tries to attach keywords to this image, and it does this automatically. And what happens is you upload the image. That's exactly the example that I gave you. You have some data in S3 stored, which is the image, and the upload triggers a Lambda function. The Lambda function then triggers a little workflow, which is called step functions. And with AWS Lambda functions, you examine the image, you store metadata, and then you continue to analyze this. So there can be lots of Lambda functions cascaded and executed one after the other. Another very popular example is Alexa from Amazon. Do you know her? You have it in Paraguay? Who's using it? Yeah, okay. If you use Alexa, if you say, hey Alexa, turn on the light, I think Alexa is always marketed as the breakthrough in artificial intelligence. For me, I think it's not so intelligent. I'm a bit disappointed about the intelligence. I like it as a cool light switch, I have to say. So if you trigger it, if you talk to it, she detects you. She's got 7 microphones. She knows where you're standing, where you're speaking to her. If you want to say something to her like, hey, Alexa, do you like this conference? She's creating a JSON structure. And actually, the JSON structure contains an intent. This is what you want to do. And then it detects which intent is this, like how is the conference? Do you like the conference? There could be synonyms for this, which are called utterance. And then at the end, it's calling a Lambda function. So this is the Lambda function executing. And you can tell here it says the intent for the OTN tour was called. So you can extend the Alexa with your own skills, and then you write a small Lambda function, which is then automatically called if you speak to Alexa. I was trying this in a small demo. I didn't bring her here, but you could try it yourself then. Pay-per-use, you pay 20 cents for 1 million requests. So if you run it like once a week, you can run it forever. There's some good case studies where people found out that if they change from a traditional implementation to API gateway, Lambda function, and serverless, the pricing drops 2 orders of magnitudes. Now again, imagine why, because you only use it for a very little time, and then you only pay it for a very little time. And actually the same thing is true if we talk about security. Has anybody seen this film Gone in 60 Seconds? Nicolas Cage, Angela Jolie? I haven't seen it. I always put it on my list to see it in the plane. I haven't seen it, but some hacker, he made a presentation. It's called Gone in 60 Milliseconds. And this is about serverless. So they were trying to hack the serverless, the fast implementation of Amazon. And they did find some misconfiguration in many examples that people use, and this is why they have a too broad access right. And so they could show something how to attack the fast, but at the end it's not a real security risk. The official answer from the guys who implemented is try and attack something that only exists for a few milliseconds, and try to compare this with a running WebLogic or with a running Tomcat. If you have a running Tomcat, it's got an IP address. It's got a port number. You can try and access it via the IP address and the port number. For the Lambda, you cannot do it because it's only there when you call it. To call it, you need to call the API gateway, which is then triggering an event to the Lambda function. So it's not there if you don't call it. This is, if you call it, it will only be there for, you know, my example, 3 milliseconds. So it's hard to break. It's a small attack surface, I would say, and then it's not on the outside, it's always in the middle. It's behind the API gateway, behind the S3 upload, behind Alexa. So I don't think it's a big security risk. Now, many people talk about microservices. Are you interested in microservices, doing microservices? It seems like a trend, but there is a lot of questions, and one of the questions is, what is a microservice? The answer is, well, we try to break down the big monoliths, and we want to run them as a suite of small services. Every service should run in its own process and own its own data, and it should be communicating with a lightweight mechanism. This is a monolith, no, not this one, but this one. And what people want is they want to break it down into this. Now, if you have this, all these small services, how do you run them? That's a good question, no? How do you run them? Some people say in a Docker container, but this would be one Docker container. What you do with all the rest, you will have many Docker containers then. And the answer is, couldn't be this Lambda thing the new microservice? Wouldn't this make sense? Isn't Lambda the new Mu, no? Does it count as a microservice, this serverless Lambda function? The answer is, if you look at the definition from Martin Fowler that I just gave you, the answer is yes, it counts as a microservice. Now it's a perfect implementation for a microservice. If you try compare this Lambda-based implementation to maybe running Docker containers with Kubernetes, the benefits are obvious, I would say. The benefits is, this is really serverless. You don't really need IP addresses and servers because all this is done for you. You never configure the scaling. You have true pay-per-use, And all this, I think, you perfectly understand now, no? So it's a very high abstraction. If you want to do something with Kubernetes, the advantage will be in a Docker container, you can run whatever you want, any language, how exotic it might be, you can run in your Docker container. You don't have those resource limits like the maximum execution time of 5 minutes, like 1024 processes or threads. You don't have this vendor lock-in because of the event data that is sent to you. So, advantages, disadvantages, but let's say it's the classical question, do you want more abstraction, more quality of service, or do you want to have more flexibility? This is the kind of trade-off that you're facing. So Mr. Cockcroft, the guy from Netflix, he said, 10 years ago we were doing monoliths, 5 years ago we were doing the classical microservices, and today we write these things as Lambda function, as fast as function as a service. So to summarize, it's too long, didn't read, too long, I couldn't pay attention. Fast function as a service, in my opinion, is kind of subset from this broader serverless, but Amazon is using serverless like a synonym for function as a service. All the major cloud providers support it. Oracle will come soon. It's event-driven, very important. You cannot just call the function the method. You have to send it an event somehow. This is also why it's asynchronous. It's stateless, and it won't replace other cloud services. It will just add as a new building block to these other cloud services. So it integrates with the rest. It's not meant to replace all the rest. This is how sometimes it's marketed, but it's not true. It's not going to replace all the rest. I think you do have some degree of vendor lock-in because of the event structure, of the JSON structure that you send to it. If you think about using serverless for microservices, you probably end up having more than one microservice, and then you have the question, how do you deploy 117 microservices as a Lambda function, or as 117 Lambda functions? There's 117 times you need to do the same things like create access rights and stuff. So there are frameworks, and one of them is called serverless.com, and they kind of facilitate, make it easier, the deployment of Lambda functions. And at the end, Lambda could be the new mu. So maybe we're doing more and more Lambda functions or fast function as a service instead of the classical microservices. So thank you for being here. Thank you for listening to this presentation. These are my contact details. I will upload the presentation to SlideShare, and then you can just get it from there. So maybe tonight I can share it with you. So thanks again for being here, and I'll do another presentation which is much more product specific. It's about running WebLogic in the cloud. There is a service from Oracle, it's called Java Cloud Service, which is in one of the other rooms. I forgot which one. So thank you, bye-bye.
Hello? Sorry. So hello, everyone. Thanks so much for attending my session, and thank you so much for having me in your beautiful country. It's my first time here, and everything couldn't have been better, so thank you so much for the invitation. This is Kafka and the Event Hub Cloud Service. So what I'm going to do in this talk is I'm going to spend some time talking about Kafka in general. I think it's really important that you see the value of what Kafka is. And then we'll talk about the Event Hub Cloud Service, which is Oracle's implementation of Apache Kafka in the cloud. So just a little bit about me. I've been doing this for about 20 years. I work in traditional data warehousing. I also work in big data, fast data, streaming data, and that's really what my company focuses on. I'm the owner of a company in the United States called Red Pill Analytics. We're about 30 people, so we're a services and a products company. If you're interested in following me on any of these social media avenues, I'd be honored. And just a little bit more about my company. We are an Oracle partner. We're also a partner for a lot of other cloud vendors. We're a cloud enablement company specifically for analytics. So if you have analytic workloads that are currently on-prem, we work on on-prem as well. But our main focus is to try to get you into cloud platforms that make analytics easier. There's a lot of great open source and cloud products out there for analytics specifically. Analytics, BI, reporting. So hopefully I'm going to have time to do a quick demo at the end of this. And if you want to send a quick tweet using this hashtag, you might be involved with that demo. I'm going to pull some data from Twitter. So if you're interested in maybe having your tweet show up in the demo, please tweet something. And then finally, the last thing about me, I have an online talk show about analytics, BI, data warehousing, big data, etc. It's called Real Time BI with Kevin and Stuart. And we always have a couple of guests on, and we just spend about an hour talking about some of the trends of the day. If that interests you, then give it a watch. So I want to start with a little bit of a history lesson, kind of on analytics, data warehousing, sort of where we used to be versus where we are today. And I want to talk about the traditional data warehouse. By the way, I'm gonna talk about using some new concepts and new techniques for data warehousing, BI, and analytics. I still very much believe that there's a place for the traditional data warehouse in an enterprise. I just don't think it's the only solution now, nor is it the only solution a single organization should have. And I'm going to dive into that just a little bit on why I believe that. So for years, I've been doing this for 20 years, and as long as I've been doing it, at least save the last 3 or 4 years where it's been more big data and streaming platforms. But this is pretty much the universal way that we built data warehouses. We would use some sort of a ETL process, typically batch, right? Run overnight or multiple times through the day, but still very batch oriented. We would load a data warehouse that was relational in nature, right? Usually the Oracle database. Some other databases worked there too, but traditionally the Oracle database was the biggest player. And then you would put some sort of a BI tool or analytics tool on top of it, or multiple BI and analytics tools, which was usually the case. So this was pretty much the canon on how you would do things, the accepted way that a major organization or an enterprise would build a data warehouse. And there's still a lot of this going on, and it still has lots of value. But what I will say, and what I saw over these many years of building this, is that if you had an analytics use case, or you had a requirement, or you had some reporting or BI requirement, you were usually forced to use this model. Either model it, ETL it into a traditional data warehouse that can be reported on with a traditional BI tool, or your use case is dead. You've got to make it fit in this model. And I think that today's tools are challenging that paradigm. There's several use cases, and frankly, some of these use cases are 20 years old. They're not new. They're just use cases that were usually ignored in the past, usually because the technology did not support them. One of those use cases is real-time events, processing data from some sort of source system immediately after they happen and acting on that event. So Frank just showed you how a Lambda architecture is event-driven. Most modern development frameworks are in fact event-driven. The problem, we've always had analytic events as well. Some sort of calculation tells us that something has happened. It takes way too long for a mobile device to act on an event if you're first ETLing it into a data warehouse, transforming it, and trying to report on it with a BI tool. That's just never going to satisfy an up-to-the-minute real-time use case. And as I just alluded to, mobile analytics, bite-sized morsels or bite-sized pieces of analytics. You're not running your entire analytics capability on your phone, but when you have a mobile app that's delivering analytics and it's in your pocket, whatever it delivers is usually pretty important. It's actionable. And we need a framework for processing data that allows us to be actionable. Search. This is a use case that has been around for as long as data warehouses have been around. It's just usually been ignored. Try querying your data warehouse for the color red. So, well, what dimension? Product, customer, customer description? No. Search your entire data warehouse for the color red. Relational technologies do not excel at that. Elastic and other sort of search products do excel at that. So why not use the best tool for the job? So what I'm challenging here is not that the relational data warehouse doesn't have value. It does. It has value for closing the books. It has value for financial reporting. It has value for one version of the truth. It's the only place that really happens. But it does not have value for trying to do search. You should use a search tool for that. And finally, machine learning, which frankly, in the analytics space, machine learning is changing everything we do. So all of those functional logic that we used to have to sit down in front of some sort of tool and write can be guessed or predicted or learned by a machine now simply by looking at enough data sets. It's changing the way we approach a lot of things in analytics. The problem with the relational data mart or relational data warehouse when it comes to machine learning is if you've transformed all your data already, there's nothing for the machine to learn. You have already prejudiced your data in one direction or another. A machine does not take prejudicial views of data. It just works through it and tells you the patterns, tells you what it sees. If you transform your data first, there's nothing for that machine to gain from that. Does that make sense? Hopefully? Yep. So the next thing I want to talk about, and Frank really got into it quite a bit, is microservices. And what I want to talk to you about is analytic microservices. So as Frank was talking more about sort of transactional or OLTP, he didn't really get into specifically what he was talking about, but that was sort of the direction it looked like to me. I want to talk about analytic microservices. And that's the idea that you might have multiple distinct, capable, and separate ways of reporting on your data in different platforms. And if you choose to go that route, it's a very innovative route to go, but you need some sort of glue some sort of a hub to serve as the center of all of those differing data platforms. That used to be the relational data warehouse. I'm going to challenge that notion that it should be today, and I'm going to argue that it should be Kafka now. It should be a data streaming platform. So if you look at a definition, also my example comes from Martin Fowler, and you probably can't read that, right? Some of you maybe. But it's basically the idea that a microservice is a distinct application that runs and innovates on its own and connects in some way to other similar services. And what this does is this makes release cycles easier. It makes development, it supercharges development in such a way that smaller teams can build purpose-built applications for analytics without having to worry about what everyone else in the organization is doing. Data warehouse development usually was very, very slow, okay, because it was so centralized. We talk about the microservice today. The antithesis, or the antonym, or the opposite of that, is the monolithic application. Okay, so that's the terminology we use for those big, all-encompassing Java applications that you deploy with one massive ear or WAR file, etc. We tend to call that the monolithic system. And I will argue that the data warehouse of years past fit nicely in the monolithic category. What microservices allow us to do is to take one of these central or monolithic applications that has very distinct capabilities, that all sort of sit in the same area, and enables us to break them up. Okay, break them up, but not only break them up, but keep them separate on purpose so that you can innovate at different paces. You can release to production when you're ready, not sitting around and waiting for someone else to finish something, okay? And this also gives us the ability to, over time, modernize our architecture. One of the reasons that so many organizations have old, legacy, aging applications that they can't turn off or migrate is because they're monolithic. They're everything. They're huge. These things can be replaced and modernized at different paces much easier. So the overall stack, or your overall enterprise technology stack, will just naturally and dynamically modernize over time if you'll split these things apart, okay? These things are typically organized around capabilities, some of the things I was talking about. And we're really just talking about using the right tool for the right job, but with something like Kafka, which I'll get into in a little bit, serving as the plane, or the data plane, or the data fabric for being able to tie all these things together such that they all share the same central data, okay? So they are separate intentionally, but connected in such a way because Kafka will drive all of them from a data perspective. And the innovation of each of these things, innovating at their own schedule, on their own pace, but still using that Kafka data fabric to tie it all together and sort of be so that you're building, they're building blocks for an all-encompassing data or analytics application or capability. So, okay, you might be saying, Stuart, I get what you're saying. Right tool for the right job. We've heard that in a lot of different areas, right? And that has merit. But isn't this a data integration nightmare, right? Do you really want to write or build all of these interconnected applications to talk to one another? So life without Kafka is just that. And Kafka was invented at, or developed or built at LinkedIn. The people that built it left once it was done and founded the company called Confluent, which is still the corporate entity sort of behind Kafka. And this is exactly what they had at LinkedIn. They were experimenting with new technologies, trying out new things, and building platforms on the best available, capable technology they could find at the time. But these things naturally had to talk to one another. If you had built over here an application for managing, finding new connections, following new people, getting linked to new people, but over here is a completely separate application which drives your analytics for trying to drive revenue somehow, inevitably those things are going to need to talk to each other, or at least the capability for them to share the same data set is going to be important. So what they built at LinkedIn that eventually became Kafka is the idea of the streaming platform, okay? And that is that these apps don't all have to talk to, or these microservices don't all have to talk to one another when they're analytic microservices. They all just have to talk to Kafka. A single ingestion set of APIs. So when you have data that you want to make available to the rest of the analytics business or the rest of the analytics organization, one API that you have to, or one platform that you have to ingest data into. When you need data, a single API or platform that you go get data from. Java, REST, we'll get into that a little bit, but it's got all the different APIs that you would be interested in. So it decouples, hope that translates, it decouples the source of the data from the target. You don't worry about what the downstream implication is of your data when you ingest it. You don't have to make those decisions at the time of ingestion. And another important point that I really want to make is, at least for the organizations that are really invested in Kafka, they're not just building the BI platforms of old, right? So these dashboards, reports, etc. They're building applications that interact with data and often deliver that data to their customer, right? So bear that in mind. A data warehouse was typically for internal use only. So SLAs, downtime, batch processing, it was internal customers usually, and we just accepted those constraints. What about when it's your customer that's sitting around waiting for data or analytic capabilities? So this is why streaming has really supercharged the analytics world, is because every app, every web service, every software as a service, SaaS offering, they all have APIs, and they're all invested in data. All of them generate data, and that is one of the real capital that you get from these services, is the data they generate. So when that data is now important for your customer, it matters how quickly you process it, okay? So Kafka is not just reports and dashboards, not just for delivering reports and dashboards, though it's very good at that as well. So let's get into what Apache Kafka is. So one of the ways I like to describe event processing, or streaming processing, is I like to use an example. So I like to draw a little picture using the Oracle database to try to get across to you what Kafka is and why it's so different. So here we have an Oracle database, and maybe we have 4 tables in it. And we think of these tables as the source of truth for the database. Whatever's in the customers table, that's our gold copy. That's what we're interested in. That's the source of truth, right? But a relational database is only about delivering to you state, the state of the table, not the transactions that led up to that state, right? Does that make sense? You understand the difference? So if you want to think about the Oracle database, the source of truth for the Oracle database is really the redo logs. If you're in the middle of, if you have a disaster or the system crashes, that's where the Oracle database goes to apply transactions and make sure your state is correct. So that is sort of the source of truth. It's a commit log, okay, of everything that's been committed. I like to use my company as a little example of the difference between state is what's on the top, and events are what's on the bottom. So I start off, I'm a private, Red Pill Analytics, it's a private company. Maybe we issue an update and say, now we're an LLC, we're real now, right? We've incorporated, to use the term in the States. And then maybe one day, hopefully, we go public. And so we issue another update. So a relational database, for the majority of its life, and all the different products or types of databases that are out there, are usually interested in delivering to you state. Now, it's a happy coincidence that the Oracle database is multi-versioned, and it uses the undo space to manage your version from your version from your version. And we were able to sort of hijack that technology into something called flashback, and even flashback versions between. So really, the Oracle database can give you, assuming you have enough undo, the view at the bottom, but it's not its primary purpose, okay? Kafka's primary purpose is to talk about events. It's not, you can get state from it. In the API, there's K-table and K-topic, or KQ, when you look at the objects. So you can declare in the Kafka API, give me the table, and that's Kafka's way of saying, I'm interested in the state. So give me the latest record for every unique entity and don't worry about the events. So it can do that, but it's not its purpose. If you consume a topic in Kafka, you're getting events, you're not getting state. And you're getting events streaming in real time, okay? So that's its purpose. Hopefully that makes sense. So when you look at what Kafka wants to be the redo logs for your entire enterprise, not just one database. So as you have data, you ingest that data into Kafka. It becomes the source of truth. When Kafka first started gaining sort of traction in the market, it was often, there's a retention policy you can set and tell it you want to keep data for 30, 60, 90 days. Most people implementing Kafka today are turning that off. This becomes the gold copy of data for all applications. And it makes replayability of events very, very simple. We'll get into that as well. Does that make sense? So let's talk a little bit about the architecture. And everything I'm talking, so the Event Hub Cloud System, which is what's in my title, and we'll get to that in a few, but it truly is pure Apache Kafka in the cloud. Now, Oracle has plans to customize it, put APIs around it, mostly additional sort of Oracle APIs, but that's mostly about how it's going to interact with other Oracle Cloud services. The pure Kafka APIs that I'm going to talk about now are available in Event Hub exactly the way they are if you installed this on-prem. They just manage all of that hassle for you. So it's pure Kafka. So everything I'm saying is applicable to the Event Hub Cloud Service, Oracle's cloud service. So in Kafka, you have the concept of a topic. Now, you can roughly equate a topic to a table. I think if you're thinking about what to put, how many topics do I have? Do I break this down into multiple topics or have a single topic, etc.? Those sorts of questions are similar to table design questions. So if you look at but the difference is there's no DDL for this. There's no schema. It's kind of just a blank palette. And you can put whatever you want in there. Now, typically we put data sets like JSON or Avro where the schema is embedded in the record, right? But there's nothing keeping you from just dumping whatever you want in there. So this is schema on read versus schema on write. The value of Kafka is you don't have to model and design to ingest your data. You just start ingesting it, okay? Don't worry, you got column changes, column updates, just keep feeding it. Nothing's gonna break. Now when you pull it, you might have some work to do, but wouldn't you rather have the work to do and ensure that the data gets ingested than to have a bunch of stuff start breaking because someone changed the length of a string? That's not the way Kafka thinks. It's very much like Hadoop in that way. Topics are partitioned. You can have a single node cluster of Kafka, nothing keeping you from doing that. But in general, we cluster Kafka because that's where we get the value. You don't have to back this up. You arguably should DR it. A lot of organizations do DR it, but a lot of organizations don't. So we partition it for two reasons. So the partitions sit in multiple things called brokers. And think of broker roughly as a node, a machine, a virtual machine, whatever. We partition it for failover, right? So that we duplicate the data across X number of nodes to make sure that losing a node means we don't lose data. But we also do it for read concurrency. Kafka's smart enough to know that it's got data in multiple places, and it will parallelize reads to pull data from multiple places, okay? Ensuring that one consumer is pulling it from one consumer is pulling it from another, etc. We generally think about this as our Kafka cluster. There's some other pieces that come into play. Zookeeper, which is sort of the brains, which can run on any of these nodes or another one that kind of manages the cluster, keeps it's sort of the boss. You can also run multiple copies of Zookeeper, okay? When you run in, say, Cloudera distribution or MapR, you're able to configure Kafka running on however many clusters you have in that distribution, and usually you'll declare Zookeeper running on multiple versions as well. We have the concept of producers, so those are the things that are putting data into Kafka. We have the idea of consumers, and those are the things that are pulling data out of Kafka. We have APIs for both of these. It was originally written in Scala, but those have been deprecated in favor of Java APIs. We also have REST. We also have interactive queries, which is a SQL layer that allows you to query Kafka with SQL. So there's a lot of ways to put data in and out of Kafka, and we'll talk about that a little bit more as we go on. Then we also have what's called Kafka Connect. So Kafka Connect is the sort of the newest entry in the Kafka suite. And this is an abstracted framework for writing connectors. So there's hundreds and hundreds of connectors built by both Kafka and the community for connecting to relational databases, JDBC, S3, Salesforce, whatever you might think you want to connect to, either as an input or an output. This is the framework that makes it very, very easy for you to write these things, okay? So Kafka Connect is the framework for building pre-built connectors. So you will sometimes hear that you've got to write a lot of custom code in in Kafka. You have the choice to write a bunch of custom code in Kafka. You certainly don't have to. And the final thing that as far as just pure architecture that I want to talk about with Kafka is perhaps the thing that makes it the most special or the most valuable or really different. And that is the idea of offsets. So every time data is read into Kafka, every time a message is put into Kafka, Kafka serializes those messages and declares them with offsets. So you kind of think of them as record IDs, right? So it manages at the topic level, which sort of a unique ID per message, calls them offsets. And it manages which offset multiple consumers are at, okay? Just out of the box. There's no configuration here. The first time you call Kafka with a consumer group, it says, haven't seen you before, but I'm going to start tracking the offset that you've read, okay? So the real value here is that as you have multiple consumers, Kafka manages what your search application has seen what your events processing system has seen, what your data warehouse has seen, et cetera, et cetera, et cetera. So this is what makes analytic microservices possible. All you have to do when you go to get data from Kafka is use the same consumer name that you've always used, and Kafka will say, yep, I know what records you've seen. And if you're running with a streaming capable application such as Spark or Kafka Streams, which is their sort of version of Spark, there's really no back and forth between it. It just constantly streams out, okay? So it's really fast and really capable in that way. All the while that this is going on, you can have multiple producers dumping data on the top. Doesn't matter, just manages it, okay? So this is really the glue that makes a microservice-based analytics platform possible, is that you don't have to write a bunch of custom code to manage which data has been seen by which platform, okay? Now, Event Hub, which is in the title of this talk, and it may seem somewhat de-emphasized in this talk, but that's simply because it is Apache Kafka in the cloud. And at this point, that's kind of what it is. I mean, and I don't mean that in a bad way. I mean that in a very, very good way. We're able to go into the Oracle Cloud. We're able to spin up our size of Kafka. It's very easy for us to configure number of nodes, shape of those nodes. It's pretty easy for you to change that shape over time. Okay. Also notice that the REST proxy, which is a separate service, often it's run on the same brokers that form your Kafka cluster when you do that on-prem. Oracle doesn't do it that way in the Oracle Cloud, and it's fine that they don't. It's actually going to create a separate cluster over here just for your REST proxy. So this proxy is simply a REST to Java translation layer, so that you don't have to write Java code. If you want to put data in or out of Kafka, you can write simple REST calls. So if you're writing JavaScript applications, if you're writing Lambda functions, if you're writing whatever, something serverless that really speaks REST, feel free to use REST as your gateway to the Kafka cluster. So Event Hub Cloud Service Topic Service is the last thing I'll really say about that is, think of this as schema as a service for those of you that are familiar with the Oracle database in the cloud, okay? Or any other database cloud service. Typically you go say, I'm going to provision some database in the cloud, and usually you provision either a whole database with varying degrees of responsibility around administering it, but do you want the whole database? Or you know what, do you just want a place to create tables, place to issue updates and deletes against, without worrying about all of the infrastructure? So that's what this topic service is. You go into Event Hub and you declare a topic, and you just use that topic. And you don't worry about the cluster, managing the cluster, etc. So when you look at my abstract for this conference, there was a piece of functionality that I was really banking on that's not there yet in the Oracle Cloud. So that was the ability for you to ingest data in Event Hub and have that data automatically flow through into the Oracle storage object store, okay, which is Oracle's version of S3 that you just saw Frank talk about. Okay, that piece of functionality is not there yet. So what I'm going to do is I'm going to talk about how you would do an Event Hub to AWS S3 architecture for your data lake. Okay, it's reasonably similar. So we're going to tie in AWS, but just so that I'm using as much of the Oracle Cloud as possible, I'm going to run a tool called StreamSets, which is sort of a big data streaming development platform. But I'm running it on a container in the Oracle Cloud. So I am, putting in a healthy dose of red in there. So how do we get data in and out of Kafka? There's a couple of different ways. Primarily, if you're not going to use a pre-built connector, you're going to probably write some Java or some REST. Now, in Java, you have the ability to use some higher level programming classes or some lower level, depending on how much control you really need of interacting with your data. Quite frankly, the high level classes are pretty good. We have Kafka Connect, which is the framework which allows us to build pre-built connectors. And those pre-built connectors use the Java API underneath the covers. We have the REST proxy, which we talked about. And we also have other third-party tools. So most ETL tools, one second. Hey, Nelson. Nelson, do you guys know when I'm supposed to be done? Okay, all right. And then almost all of your third-party data ETL tools, even your traditional tools like Informatica, Oracle Data Integrator, Talon, some of those data warehousing ETL tools that you think of from more of a traditional stack, all treat Kafka as a first-class citizen now. So they can read and write from Kafka. So even if you have a traditional data warehouse being loaded with an ETL tool, if you've got the most recent update of that ETL tool, there's a really good chance that you could introduce Kafka in your architecture without a whole lot of work. When you look at all the different connectors, pre-built connectors that have been developed by both Confluent, the Apache Kafka organization, as well as the community as a whole, these are some of the list. It's literally hundreds. Okay, so these are some of the pre-built connectors that you can use, right now. It's pretty much anything. If you need to connect to a data source, there's a good chance somebody else needed to, and there's a pretty good chance that somebody wrote that. Okay, so your mileage may vary on some of the. I don't know if that translates. No warranty for the community versions, but most of them are pretty good. They're open source, so you can get your hands dirty and troubleshoot it yourself. I just want to show you a couple of examples of Kafka Connect without really getting into the code itself. I just want to show you kind of the structure of a Kafka Connect project. This is for the Kafka connector for moving data in and out of S3. This is the Kafka connector for interacting with JDBC data sources. So anything that you've got a JDBC driver for, Kafka can connect to, both from a source or a target. Typically you have what's called the connector. So over here you see S3 sync connector. And that's the class file that's kind of the brains of the connector. Okay? It's not doing the actual work, but it's spinning up all the things that you've said you want and the numbers that you've said you want them at the cadence that you've said you wanted them. Okay? That connector, so S3 sync connector, will read S3 sync connector config at startup, and that's just a class file that allows you that reads your properties file where you're able to tell it all the different properties that it needs to be able to connect to something. And then you have these task classes. So S3 sync task. And that is the task that really does the work. So if you want to see the actual API calls that are going on to S3, you would look in that sync task. That's the one that's doing the work. So the connector will say, based on your properties file, you've told me you want me to spin up 10 of these tasks, and you want me to query or poll S3 at this interval. So those three things working together, plus obviously there's a bunch of other stuff as well, that's pretty much the core of how the Kafka connector works. When you look at the REST API, these are some example calls just using curl of how you would get data in and out of Kafka. So the REST API is pretty expressive. And then finally you have Java APIs. So I want to do a quick demo here, which is going to be difficult because I have to hold the microphone as well. No, that's fine. Thanks, Dan. I appreciate it. So this is just me using the Kafka Connect consumer class and the producer class. So to be honest with you, this is about as simple of a Kafka example as you could put together. But I think it does make the point. So this is the consumer. So this is what's going to read data out of Kafka. So basically you have a few parameters you set. You have this group ID, which is parameterized. You can't see it. But the group ID, and that is, what consumer group am I? So all of your applications are going to use a separate consumer group. And you don't have to pre-enable that with Kafka. You just make a call with a new consumer group. First time it sees it, it provisions that consumer group and starts tracking it, okay? When it hasn't seen it in quite a long time and that's configurable, it will clean it up. So you can say, don't ever do that. I don't want you to ever clean it up. Or you can say, you know what, you haven't seen a consumer call to get data in 90 days. That consumer's dead. It's been replaced. Just clean it up. We also see a couple of other things like auto offset reset. It's a terrible name for a simple feature of when you call Kafka for the first time to consume data, Kafka wants to know, do you want all records in that topic or just any records beginning now? Okay? That's all that says. And you have the ability in your code to go and replay, reload. It manages. So if you've got 6 systems that all need to be reloaded because you found some incorrect business logic somewhere, go reload all of them. It makes it very, very simple. The rest of it is sort of window dressing. I love and hate presentation mode on this tool. So now let's take a look at that was the consumer. I'm going to go ahead and start the consumer. Hopefully you can see that. So basically, all the parameters, I only passed a couple of parameters to Kafka to start consuming. It's going ahead and telling me all the defaults that I didn't decide that I needed to pass. And you can see it's made a connector. It's talking about how it's connected. So this consumer is now sitting and listening to Kafka, to a particular topic. And it's really just doing a while. Hopefully you can see that. And saying, while poll based on every 100 milliseconds, go get stuff from this topic, okay? Now we'll take a look at the producer. Sorry, I was already on the producer. There we go. Now we're going to produce data. So hopefully you can see that. My apologies if you can't. So what we're actually going to do is go get data from Twitter, okay? So very, very simple. I'm using the Twitter4j Java library. That's just a Java class that makes it very, very easy for you to go do searches in Twitter and pull the data. I'm also using the Google JSON Serity library, which is their way of serializing and deserializing back and forth to JSON. Okay, so I get the data from Twitter. It's not in JSON, so that's a Java library that actually returns the data from Twitter in Java objects. Not really interesting to me. So I just easily transform that Java object into a JSON representation. And there's a Google library I'm using for that. That's very, very good, by the way. It's called JSON. And then at the end of the day, all I'm doing is saying, send the record to this topic. There's my JSON file. All right, so very, very simple. Let's kick this one off as well. So hopefully some of you tweeted. Looks like you did. So this is the JSON representation of a tweet. By the way, I'll go into presentation. If you've anybody ever done any work with Twitter using the API? There's so much about a tweet. I always thought it was just a handle and text. But there is so much information just about an individual tweet. So now I'm going to pop out. You can see that these are the records that are going into Kafka. Now back to my stream sets tool. So this is stream sets, which is listening to that Kafka consumer. So basically I have a Kafka consumer. I'm able to do some transformations, and this is me loading that into an Oracle data warehouse. So the point of this sort of whole thing is I can easily load the data from a single Kafka topic with two different consumers of data to my downstream platforms without worrying about trying to figure out, to custom code logic to figure out changed records, which records have changed, which records have I seen, which records have I not seen. So with that, I think I'm done, and I'm probably running over. So do I have time for a few questions, probably? Do we have any? Nope. Thanks very much for attending. I appreciate it.
Ah, there it is. That was cool. I love the intro. Welcome back for those that have seen the previous session. I'm really excited to do the second one in this gigantic room, in this gigantic stage, and I promise I will run back and forth as much as I can, just because that's what people do on these big stages. So this is a talk about Oracle tuning tools, and my goal is to enable you to get this, to get a command center for all your SQL tuning needs, so that you can have monitors and alerts and all the kind of checks to enable you to basically run mission control for your SQL tuning needs. The way this presentation works is I will go through a lot of tools. I will probably present 12 or 15, and I'm going pretty fast. You do not have to use or remember all of them. If at the end of this talk you find that there are 1, 2, maybe 3 tools that you haven't seen before and that are new to you, then that is the goal of my session, to just give you 1 or 2 new ideas of how you can look at Oracle performance tuning. And I think it also fits in nicely with Craig's session that he's done earlier about mining Ash and using Ash to diagnose performance problems. Quick word about me. I mostly working with Oracle database tuning. That's really the most fun for me. I also do architecture around high availability and troubleshooting that. And I'm really proud to be an Oracle ACE director and an Oracle developer champion, and have Oracle and OTN support these tours and the travel for these events. So that's really, really cool, because I do love traveling and I do like to meet different user communities. If you haven't seen this before, let's do it again. I'm from Germany originally. That's where I was born and raised, and that's where I lived most of my life, in a town called Hamburg, which is a really, really cool town by the harbor. I've moved to Canada this year, so now I live here in Ottawa, and it's a gigantic country. This is bigger than Brazil, and I've only been here and there and there. And yeah, it's gigantic. I can't wait to see more of this country. The town I live in is called Ottawa. This is Ottawa in the summer. And then here's a small picture of what Ottawa looks like in the winter. All right, so people ask me, how do I pronounce my name? It's pronounced Björn, It's really hard to say, and the 2 dots make it weird. In Danish, it's even written worse with the slash through the O's, but it's still called Björn, The name is from Sweden. And it's a Swedish word and has a meaning. So the meaning of Björn is bear, also. And if you look at me, though, that's more also perezoso. I work for a company called Pythian. We do everything data related. We do managed services and consulting for all kinds of data platforms. A lot of this is Oracle, but a lot of it is other relational databases like MySQL, SQL Server, Cassandra. Well, that's not relational. But yeah, we do Cassandra, Hadoop, and a lot of exciting technologies. But I really still love working with Oracle. Oracle is really my favorite tool, and there's a reason for that. And the reason for why I mostly love working with Oracle when it comes to databases is because it has this awesome instrumentation in their code. Especially when we do performance tuning, we can see what every session is doing at any given time and diagnose any kind of problem that helps us to understand everything that's going in a database. And a lot of the other stuff, what the database is doing, like doing scanning data, processing data, that's not much different between Oracle and other databases. But just being able to see what's going on, that is gold for me. So even though we're able to see things, not everybody's doing that. So a lot of what I see people do is what I call this wrong tuning cycle. When they have a performance problem, they would take some magic silver bullet that they've heard somewhere, set some parameter, do something, make changes, and then hope that everything will be fine. And that's wrong. And I say that leads to something that I call stormtrooper DBAs. Stormtrooper DBAs, just like in the Star Wars movies, they shoot all these lasers or silver bullets, but they never hit their targets, right? So stay away from silver bullets. Use the real tuning cycle, which looks more like this, where you start by measuring what the problem is. Whenever you have a performance problem, start measuring what is taking so long, where is your time going, and then from measuring this or seeing what your sessions are doing, what your SQL is doing, try to understand what's making it slow and try to come up with a theory on how to make it faster. Then you make a change based on that theory, and after you've made the change, you measure again, and you measure that whatever your theory was and changing it has actually made an effect. And if you do these 3 simple steps, I find performance tuning is really, really simple. Because once you see what the problem is, it's usually easy to fix, or at least easy to find an explanation. Not every problem might be fixable, but at least you see and show what's going on, It really helps with describing a problem. So for me, no. That's the translation. Maybe. Anyway, so here's one example of a Stormtrooper DBA. We had a problem with the data guard standby database, and it was replicating too slowly. And the DBA that worked on this just tried all of these different things. All of these silver bullets changed a lot of parameters and a lot of things, and the problem didn't go away. And after a day of trying all of these things, they called me and said, Bjorn, can you please have a look? This is a really complicated problem. We can't solve this. We need more silver bullets. And I said, no, what you need is not a silver bullet. It's actually looking at what's happening. So I went in and I ran this command. I just said, give me the wait event that this process, MRP, is waiting for. And MRP is what runs the managed recovery in DataGuard. And I could see that I was always waiting on these two events, PX something. I have no idea what these wait events mean. I have a really shitty memory. I can't remember these things, but I can easily search Google or my Oracle support. So I searched my Oracle support for these two wait events, and sure enough, I found a note that described the exact problem that they had, and that was the exact fix for it. So somebody tried all of these things, nothing worked. It really took me 5 minutes to run this query, come up with this solution for this problem.